Professor Edson Borin is an associate professor at the Institute Computing at the University of Campinas. Prior to joining Unicamp, Professor Borin was a researcher at the Intel Labs in California, where he investigated and developed dynamic compilation techniques to enhance next-generation hardware and software co-designed microprocessors, including automatic binary parallelization, binary translation, and hardware optimization, and support techniques to accelerate single-threaded applications. During this time, he received 4 divisional recognition awards from developing techniques that improved Intel microprocessors manufacturing process. Nice. Since joining Unicamp in 2010 as a professor, Professor Borin has applied his expertise in modern computer architecture and compilers to optimize the performance and cost of running scientific and engineering computing application. Much of this work focuses on improving seismic processing and deep learning applications and cloud infrastructure to optimize the performance and cost of running those applications in the clouds. So Professor Borin coordinates the Discovery Laboratory with projects funded by the government agencies such as FAPESP, CNPq, and CAPES, by international technology companies such as Intel, AMD, Samsung, Motorola, and Cadence Test Silica, and by large Brazilian companies such as Petrobras. He has supervised over 22 doctoral and master's students, many of whom have received awards for best thesis, dissertation, and papers. So thank you very much for joining us. Now,
thank you. Oh, I'm going to use this. Is that working? Can you guys hear me? All right. So, good morning. Buenos dias. That's how I know in Spanish. So, bom dia. Yeah, in Portuguese too. So, thank you all for being here on Friday. And this is a beautiful day out there, and the city is very nice. So, I'm very glad you guys are here. And so today I'm going to talk to you about how we are using DASF, which is a framework that we developed at Unicamp, to train AI models on massive data sets. Before I dive in, I'm going to tell you a little bit about Unicamp, the place where I come from. So Unicamp is one of the 3 Sao Paulo universities, state universities. The university was founded in 1966, so it's very young, has only 60 years. And we have 36,000 students, which is interesting because half of these students, they are graduate students. Most of them are PhD and master students, which is a ratio not very common in most universities. We have an annual budget of $0.8 billion and roughly 2,000 faculty members and 8,000 staff. Most of these staff, they work on the hospital. We have a very large hospital in the university that attends most of the nearby cities. So the university has lots of teaching and research units. One of the units that we have is the Institute of Computing. I'm a professor at the Institute of Computing. We have 2 undergraduate courses. The first one is the computer science course, which was founded in 1969. It's the first CS course in Brazil. It has 55 years. We have roughly 2,000 alumni, and currently we have roughly 300 students enrolled. And we also have a computer engineering course, which has 500 students enrolled. In addition to that, we have graduate courses, masters and PhD. You can see here that we have roughly 300, almost 400 students on the graduate courses. And we also have some specialist training and extension courses that we use to teach corporate employees in the region. So we have Internet of Things, computer networks, cloud and network virtualization, and machine learning, of course. Yeah. So one thing that is interesting about the Institute of Computing at Unicamp is that nowadays we have lots of people doing research on artificial intelligence. We have 2 very large projects, which we call Hub. The first one is the Hub for Artificial Intelligence and Cognitive Architectures that is funded by the Ministry of Science and Technology in Brazil. We have more than 90 AI people, AI researchers in this hub. 34 people are faculty members or postdocs, so they are already doctors. And lots of PhD students, 20 PhD students, 17 master students. So there's a lot of people doing research there. We have also another hub, which is funded by Samsung. It's a little bit smaller, but also lots of people there, 50 people. In total, at the Institute, we have 17 professors out of 45 doing research with AI, 30 postdocs, more than 170 graduate students between master and PhD students, 16 undergraduate students. We also have 10 undergraduate and graduate courses that are targeted at these students, and they are machine learning courses, for example, self-supervised learning, supervised learning, and so on. Yeah. And also some outreach courses to train professionals in the area. So I'm one of the coordinators of the Hub for Artificial Intelligence and Cognitive Architectures. In my group, we have 14 people, 3 faculty members, and 1 postdoc, and 10 students. And in this group, basically I investigate how to, machine learning techniques, how to learn representations for data automatically. And this is a very machine learning oriented group. And I also have another group in my lab, which is called Discovery, in which we investigate machine learning and HPC techniques for seismic processing. This group is funded by Petrobras, and we have 2 faculty members, including me, and 11 students. The work that I'm going to talk to you about today is done by this group. Okay? All right, so let's shift gears here. This is the typical machine learning workflow when people are working on massive data sets. Basically, we start by developing some machine learning code, which is usually written in Python. And then this code is used by the developer to test on a small sample of the massive data set, right? Because you can't many times, often, load the data set inside your machine. So if you have a 1 terabyte data set, you cannot load that inside your desktop memory, right? So usually what we do is we take a small sample, and then we work with this sample, start analyzing the results, improving the code, until we get to a point where we are satisfied. And then we want to check if this code also works with the massive data set, right? At this point, we have to shift to another cycle, which I call scalable flow. At this point, we have to take this machine learning code, and we have to improve it to make sure it's scalable and run on an HPC cluster. And then once we have this improved code, we run it on the HPC cluster using the whole data set, and we get the full results. Then we come back here, and sometimes, many times, we're not satisfied with that. We have to improve the process. Then we keep doing this again. Eventually, we have to move back here, and so on. Okay? So it's very important to notice that this cycle here, it needs to be fast, right? You don't want to make a small test and then wait for a whole day to see the results. You want to wait like a minute or less than that. And this cycle here is usually slow. Sometimes you have to submit your job to a queue in a supercomputing center. Many times you have to wait days to get the machine, right? So it's very, very, very important that these 2 codes here, they are coherent. They do the same thing, right? The last thing you want to have is porting your code to run on the system, waiting hours or days to get the results, and finding out that the code that you're running there is not the same thing that we are doing here, right? And another thing that is very important is that you want to make sure that developing the scalable code is easy, because most of people that do this, they don't have expertise with parallel programming and parallel systems. So you want to make sure that we make these people's life easy when it comes to optimizing or parallelizing the code. DASF is about this. It's about making sure that people that work in this cycle, they have an easy time going through the HPC system. Okay? All right. So this is the typical machine learning pipeline. Usually we start with some raw data, and then you do some pre-processing. You need to clean the data, remove bad data, or sometimes you need to normalize the data. For example, if you're working with seismic processing data, these data, they have samples that range from minus 1,000 to plus 1,000. And then sometimes it's important for the machine learning model for you to normalize it and make sure it's in the range of -1 to 1. So there are some pre-processing steps here that are needed so that you can get a proper data set to train a machine learning model. Once you have that, you're still not done. You might still need to apply some transformations on the data to extract features so that your machine learning is better trained. Okay? So the first big challenge here is when using massive data sets is that storing or moving very large data sets, for example, hundreds or terabytes of gigabytes or terabytes, it's really hard to deal with. It might not be possible to store them into the available memory. And it's not only that. Sometimes the transformations that you have to apply and the pipeline or the workflow that you have to apply on this data is really complex. You have to apply several transformations to extract features from this data. And dealing with this and ensuring that the way this thing works on your local machine and on the cluster is the same is very important. More than that, if you have a 1 terabyte data set here, each one of these transformations, if they don't produce the size of your data, it's going to produce a new data set with the same size, right? So you're going to need, like, in this case, 6 times more space just to store your data before you start training your data set. So all of this makes it very hard to work with large data sets. And finally, migrating code between computer environments, for example, going from your local CPU, or even if you go to your local GPU, you still need some work to do there. But when you go to the cloud or to the HPC cluster, lots of things to do there, right? So many people here work with this, like how to parallelize codes and make sure they get most out of the machine. And you know that it's very hard to do that efficiently. So now I'm going to introduce DASF to you. And this is the workflow that we developed inside Unicamp to tackle these issues. The project started aiming at facilitating the life of people that work with seismic data sets, but eventually we realized that this would also be useful for other areas. So I'm looking for people that want to collaborate, that they need to process massive data sets, but they are working on different areas. I'm very happy to talk to you about this, so please look for me. And so what is DASF? DASF is a framework that, the name is basically a recursive acronym. DASF is an accelerated scalable framework. The first thing that DASF does is it has support for massive data sets. Basically, we have to use file formats that allow us to access parts of the data in parallel and on demand. So right now, we are using ZAR, which is a common standard, and also MDIO, which was a variation of ZAR that was developed for seismic processing. Okay? Also, we want to make sure that the API that we provide to the user is familiar. So it's based on the well-known Python and machine learning libraries. Basically, we use NumPy and scikit-learn and PyTorch APIs. So if you are programming with these frameworks, when you look at DASF, you're going to see that it's very familiar. Okay? The goal is to be easy to use and to reuse code. Another aspect that is very important for us is that the code has to be coherent when running on the local machine and on the HPC system because of reproducibility. And to do that, we ask the user to design a pipeline that processes the data. And then we ensure that the user doesn't have to change the pipeline when migrating to other environments. So we ensure the pipeline is the same. So the idea is to create one single pipeline and run everywhere. Doesn't matter if GPU, CPU, cloud, or HPC systems. Also, it's very important that it's scalable both in performance and data set size capacity. I will stress this part, data set size capacity. The goal here is if we have larger data sets, we want to make sure that we are capable of processing them as long as we are giving more computing nodes, right? So if I have a 1 terabyte data, I can process it with 8 nodes. If you give me a 2 terabyte data, I can tell you, OK, just give me more nodes, I can do that. And finally, it's open source. Okay? So this is the GitHub repository. All right, so what does a DASF pipeline look like? It's basically a computational graph. It has nodes and edges that indicates the data dependency between these nodes. They are operators. So here I have an operator called simple dataset, another one that is called fast Fourier transform, another one that converts data to a data frame, and another one that applies a machine learning technique called k-means. How do we build this pipeline? We use Python code. Basically, each one of these operators is an object that is created when you instantiate a class. And for example, here, to create this operator, I basically instantiate the FFT class, pass to it some parameters, and create an object. And then, once we create the operators, we can basically connect them on a pipeline. We create a pipeline object, and then we start using the add method to connect the edges here. So basically, for example, for the FFT operator, I can tell that X, which is the input for this operator, is equal to the dataset, which is basically the output of the simple dataset operator. So by using these add methods, I can connect all the operators here and build this graph. Finally, basically, I can just run pipeline run to run this pipeline, and I can use some method to get the results from the last operator. So the goal here is to make sure that whenever you build this pipeline, you don't have to change it when you go to the HPC system, okay? And if I have this pipeline here and I want to run it on a cluster, I could basically instantiate what we call an executor, which is responsible for adapting the pipeline to the environment. And once I have the executor, I just tell the pipeline, hey, this is the guy that's going to make sure you're going to execute on the proper environment. And what does the executor do? Well, each one of these operators, they have 4 methods that implement the same operation. The first one implements the code on CPU, the second one on GPU, and they are eager evaluators, which means that if you invoke those methods, they execute the operation right away. And it expects the data to be on memory, okay? This is very useful for when you are prototyping in your laptop, which is very fast. But when you go to the cluster, you want to do this lazily. So we have 2 versions of the code that instead of actually performing the computation, it returns an object that represents the operator and then allows you to build a graph, or the executor to build a graph, and send it to another machine to execute it, okay? And this is what happens. We build the pipeline, the DASF pipeline, and then we send it over the network to a scheduler that is running on an HPC cluster or on the cloud, for example. And then this scheduler schedules the operators of this pipeline on workers. And here you're going to notice that I'm using the word DASF instead of DASF. DASF is a well-known framework for this kind of thing, but they don't solve all the problems that we want to solve. And we build DASF on top of DASF. So we use most of its functionalities. So basically, we have a lot of workers on top of several computing nodes, and they access the parallel file system when executing these operations. Okay? So this is the first idea, is to use parallel computing transparently. The second thing that is very important in the framework is that the input data, for this to scale to massive data sets, our data has to be organized in chunks, which are small portions of the data. So here I show an illustration that pictures this idea. I have the whole data divided in 9 chunks. And most of these operators, they usually can be applied to chunks independently. They don't need to be applied to the whole data before we move the computation forward. And then in these cases, we allow DASF to choose which chunks to be executed first. In this example, I show that the system decided to execute this operator, the operator that loads the data from the disk into memory, for these 3 chunks, right? So I need memory to store these 3 chunks. But instead of doing that, I could actually just load the first chunk and then do the FFT transformation, transform the data into the data frame, then store the data back into disk, and then move to the next one. At this point, I don't need this memory anymore, so I can reuse it. So I can actually process very massive data set with little memory. That's the idea here. So we want to let DASF schedule operations and chunk pairs so it can have flexible scheduling and enable memory user optimizations. And finally, we want to use parallel file formats, MDIO and ZAR, as I said before, so that the DASF workers can actually access these chunks in parallel and on demand whenever it's needed. All right, so this is DASF. Now I'm going to tell you how we use the DASF to do some seismic processing with Petrobras. I'm going to bring here 3 case studies. The first one is called seismic phases classification. In this problem, we have a seismic data set, which is usually a volume. I'm showing you a slice of this volume here, which is called an inline. This is basically the response of some measurement that we do to understand the underneath of the Earth. Okay? So when the geophysicist or geologist looks at this, they have to find out what kind of layers we have here and if there's a potential for oil or gas in the underneath. To do that, over the years, these people, they have developed lots of techniques to enhance the image, and they call it seismic attributes computation. And they perform this computation and they change the way the image looks like, which allows them to have a better understanding of the underground. And we understand that these traditional techniques are also useful for machine learning models, so we implemented about 50 of these techniques inside DASF. And this is the instantaneous phase. When applied to this data, we get this new image here. So one of the pipelines that we implemented was like this. We have the seismic data. Then we extract 4 features, which are seismic attributes. Then we combine these features in a data frame, and we use a clustering algorithm like k-means or sum to perform the seismic phases classification. The final result here is basically for each one of the pixel or the voxel, we have a class number, and the class is indicated by the color here. All right, so the case study that I'm going to show you now is about this problem and how we solve it. This is the DASF pipeline, right? And in this, the fun thing here is that the image that I'm showing you was actually generated by the framework itself. It automatically generates the pipeline so that you can look at the pipeline and inspect it if it's doing what you want it to do. So basically, we load the data set, and then we convert it to an array. Then we apply all those seismic attribute operators. Then we combine this data into a data frame, and then we apply the k-means machine learning model. So in this experiment here, I'm not going to show you how the result of the clustering looks like. I'm going to focus on the performance of the framework. And in this experiment, we keep increasing the input file size until the system runs out of memory, right? Because there are some operators in this graph, like the k-means operator, that requires the whole data to be on the memory. And it's parallel, so we can actually use the whole memory, the aggregated memory of like multiple nodes, but it has a limit, right? At some point, it's not going to be able to process the data. Each computing node has 2 Intel Xeon processors with 36 cores and 72 threads, 394 gigabytes of memory, and 4 Tesla V100 GPUs, which have 32 gigabytes of memory each. This graph here, it shows what happens when we keep increasing the size of the input data. So in the first one, in the blue, we are using only a single node to do the processing. And of course, the execution time keeps increasing because we are processing a larger data. But then eventually, the line stops here because we cannot process larger data because of lack of memory. Okay? Only one node. And at this point, I'm trying to process a data that has roughly 17 gigabytes of data. It's not that much. But curiously, most of the work, the research work in this area, they use data like 1.3 gigabytes or 5 gigabytes because of that, because they don't have a framework to experiment with large data sets, right? So they use toy samples. All right, so I'm limited to 17 gigabytes, which is roughly 50 gigabytes of the data frame size. Remember, I'm computing a lot of seismic attributes and putting them together on a data frame, right? So it takes more memory than the input size. So this is the data frame estimated size. If I move to 2 nodes, then I manage to process data up to 30 gigabytes. 4 nodes, up to 50-something gigabytes, and with 8 nodes, I can process data that are larger than 100 gigabytes. Okay. Also, you can see here, if I draw a horizontal line, oh, I'm sorry, a vertical line, we can see here that for the same size, the execution time drops almost linear when we have more nodes. Okay? So it's scalable in performance too. But the more important thing here is that I want you to keep in mind that it's scalable in data set size. I can add more nodes and process larger data sets. So this is the chart, the same graphic, but now when I change the pipeline to use SOM, which is another clustering algorithm, this is a more time-consuming algorithm. So here we have like up to 5,000 seconds, while here the pipeline runs, it may take up to 30 hours to run, okay? However, you may notice that we are capable to run the same pipeline with this guy, even though it's slower, we are capable of processing very large data sets. Actually, the same size, right? Because the limiting factor here is the data frame size, and this is the same in both pipelines, all right? Of course, we also want to, so all the results that I showed you here, they were for CPU only. Now I want to show what happens when we go to the GPU, right? So, and this is also very easy to change for GPU. Basically, it's much faster, as you can see here. So we are talking now about up to 80 seconds. However, because of the amount of memory that we have on the GPUs in this system, we're limited to input files up to 22, 23 gigabytes. So it's a trade-off, right? To put that on perspective, if I zoom in here in this graph and try to plot these curves, they're going to be plotted in this square here, right? So basically, it's up to 80 seconds, which is very little here, but also we are limited on the data set amount, right? To give you some perspective, using 8 nodes with 32 GPUs, it takes us to roughly 75 seconds to process a 22 gigabytes data. Here with the CPU, the same data, which is indicated by this red line here, would take like 1,300 seconds, okay? Well, all right, so what are the key takeaways that I want you to have from this experiment? First, DASF scales both in performance and data set size capacity. Remember, larger data sets can be easily processed with more computing nodes. GPUs are much faster and preferred if the data set fits GPU memory. However, CPU is still very important for massive data sets because of their larger memory, okay? And very few code changes. I didn't show the code to you here, but I assure you, it's very few code changes to scale the experimental local code to the HPC system. Basically, we simply define a new executor. All right, so how are you on time? We're good, we're good, yeah. Oh, it's okay. So in the second case study I want to show you, we try to understand the impact of having different file formats on the machine learning pipeline. So SegWi is a file format very commonly used by the industry. It's mandatory by the Brazilian National Oil Agency. So basically, if a company is exploring oil and gas in the country, they have to give the data to the agency. And this is the format that required companies to give the data. However, this format is not HPC friendly. It's very sequential. So if you want to access like data in the middle of the file, you have to keep looking for the whole file to find the data. So usually what we do is that we don't work with this kind of data. We convert it to a more friendly data. And then we work with the better data, and then finally we export. But DASF allows you to work with all these kinds of data sets, right? The data formats. So what we did here is, so what happens if we try to do some operations on the data, reading directly from the SegWi format and then producing the SegWi format, compare it to when we use ZAR or MDIO. In the first case, we don't have to do data conversion, right? But it takes 129 seconds for a 5 gigabytes data set for me to compute this using the framework. And we can't do that on the 292 gigabytes data because the system breaks. It runs out of memory because this data format expects you to load the whole data on the memory, and we can't do that. When we use ZAR or MDIO, it takes only 8 seconds for this data set, for this data set, and a little bit less than 5 minutes for this big data set. But the point here is, as I said before, we have to convert this data, right? And it takes time to do that. So we still don't do that in our framework. This is future work to do the data conversion, but we use third-party tools to do that. And when we try to convert SegUI data to MDIO, when we do that for a small data set like the Parihaka, it takes 23 seconds, right? And when I try to do it back to SegUI, it takes 262 seconds. So if I want to use this pipeline here, it's only 8 seconds, but I have to pay 23 plus 262 to convert the data, right? Which is going to be slower than this one. However, it's important to keep in perspective that usually what we do is we convert the data, and then we keep working with the same data, right? So this overhead that we have actually dilutes, and you don't see that on the long run. But even so, we want to optimize this. This is future work. The point here is to show you that if you use the proper file format, you can speed up the computation, and you can enable processing of larger data sets. So the key takeaways here are DASF allows you to use HPC-friendly file formats like ZAR and MDIO. And when you use those file formats, you get faster I/O and scalable, enabling massive data sets processing. Okay? And as future work, we want to implement more efficient file format conversions. If you have this kind of solution already, let me know. I would be interested to learn about that. All right. So for the third case study, I want to show you a problem that is very common, and people usually they don't pay much attention about this, but it's very important. So usually when we train a machine learning model, this machine learning model, it expects an input shape, an input format. For example, if you go to the PyTorch website and download one of those pre-trained models with ImageNet, those models, they were trained to process images that are 224 by 224 pixels. But then you have an image here that's much larger than that, right? So what do? You process it in patches. Basically, you split the data in several patches, and then you use your model to process these patches, right? What's the problem with this? Usually, machine learning models that are applied to images or volumes, they take advantage of the neighborhood information to extract information. And when you do this in patches, when you're on the border, you don't have much neighborhood information because you don't know the data on the other patches. And then the quality of the result is better in the middle of the patch than on the border. So how we solve this problem? We use overlapping patches. So I create another patch here, and I do the inference in this region. Now the middle of the patch, which has good quality, is actually offering more interesting results than the border of the previous patches, right? So I can keep doing this. And I can have several sets of overlapping patches, and then at the end, I can just combine the results. I can use voting, soft voting, hard voting. There are several strategies to do that. Averaging, okay? And you can do weighted average to make sure that the results in the middle of the patches, they have higher weight than the other results. There are several strategies here. And this is very important. Most people in academia, when they show results, they don't bother looking at this. They just pick some patches on the data, and they apply the model there and check if the model is doing a good job there. But at the end, if you want to move to production, you need to do this, okay? And here we try with 4 cases. First, we do the patching, but with no overlapping patches. Then we do the patching with one set of overlapping patches, like the blue one here. Then using 3 sets of overlapping patches, and then 9 sets of overlapping patches. And we see how it affects DASF, okay? So this chart here shows the speed up of the system when processing a 292 gigabyte seismic data set. So This number is very often in my presentations because this is private data that we use. We can talk about the data, but I can talk about the size of the data. And this data, when we increase the number of computing nodes, you can see here that the system scales very well when we are working on the case 4, which has 9 sets of overlapping patches. The reason for that is that we have lots of data reuse, right? Most of those overlapping patches, they are working on the same set of data. So we don't need to keep reloading those data from the disk, right? The data is there, sitting on the memory. We just need to compute that again, right? So it's much easier to scale the performance up. But even in the case where we don't have overlapping patches, the system scales roughly well. 8 nodes, we get like a 4 point something speed up, which for the size of this data is pretty decent for us. And yeah, that's it. So the key takeaways that I want you to have in mind about this case study is that I didn't show you code, but I want to argue that it's very easy to use the API for the patch to the inference. Basically, you just take your model, you encapsulate it on an object, and tell, this is the size of the patches, and these are the offsets that I want to have on my overlapping patches. That's it. Then it does the whole job for you. So there's a lot of, it's a great degree of freedom when defining the overlapping patches, and the performance scale very nice with more computing nodes too. All right. So these are my conclusions. I want you to remember that DASF is a general framework that enables machine learning on massive data sets. I wanted to remember that it's general, it's not only for seismic processing, because I want to find people that are willing to collaborate with me on new domains. It's also scalable both in performance and data set size capacity, which means larger data sets can be processed with more computing nodes. And we had several successful applications on seismic processing with Petrobras. And it's open source. You can just go there and check it out. I would like to thank Petrobras and FAPES for the funding. Also my partners at Petrobras, Daniel and Alain, which has been great in the discussions and technical support. My research team, of course, they did all the work here. And the Discovery Lab, the lab that I run. The Institute of Computing for providing not only infrastructure, but also all the environment, classes, and support to training my students. LNCC and Senai Cimatec for access to their supercomputers, which was very important for this research. Finally, but not least, I would like to thank the organizers of the conference for being here today, for putting together this awesome event. And before I finish, I would like to talk a little bit about this person. This is a dear friend of mine, Mauricio Breternit. He passed away yesterday. And he's a brilliant researcher. Some of you here know him. He was living in Portugal these days. He studied at Instituto Tecnológico Aeronáutico, so Jaime. I'm sorry. Some of my friends here know him. This person was very special for me because he was one of my most important mentors. He actually helped me to get here where I am today. He's a very kind human being and a brilliant researcher. He was capable of connecting things from different areas and baffle you. Yeah. So, fun thing, this is a picture of his Google Scholar. You should be familiar with that, right? Look at the things that he does. He did high-performance computing, computer systems architecture, compilers, machine learning. So I ask you guys that know Mauricio to join me and honor his name and by remembering him. And yeah, thank you for your time.
We still have time for questions. So first, thank you, Edson.
Yeah, sure. I should thank you guys for putting together the conference. Yeah, very nice. Jaime. Yeah.
Hello. Okay, working. Congratulations, Borin. Nice talk.
Thank you, Jaime.
DASF is based on pipeline and domain decomposition. Okay, pipeline
Yes, you can say
has
that.
stages,
Mhm.
and how do you handle load imbalancing on those stages? How does DASF handle that?
All right, that's a very good question. Let me see if I can put together, select a slide here to discuss that. So this is an assumption that we have, right? So most of these operators, they are map operators. They can be applied independently to chunks of the data. When you have that, you basically have like a bag of tasks, right? So all these combinations of operator and chunks, they are independent on the same level. And then DASF can actually decide whether to do lots of them in parallel or to take only one of those and run the whole pipeline on top of those. The trade-off is parallelism versus memory consumption. And it takes advantage of that to improve. That's the schedule. Yes, yes. That's the key idea. Yeah. Yeah. Thanks for asking that.
More questions?
And I'll be around if you guys want to talk to me about this. So just look for me. Yeah.
It's very interesting, your first case, that you have a machine learning application that has a better performance on CPU than on GPU because of memory.
Yes.
That's very interesting. And so we are going to have the new machine now in Santos Dumont with different architectures, and that will be very nice for you to test. And
I'm looking forward to that.
Yeah, we too.
Yeah.
So no more questions, and so thank you very much for joining us.
Thank you.
So and we can go to.
Thank you.
And maybe the picture.
Picture, of course. Let's go. All
This is
right.
yours.
Oh, thank you.
It's yours. This is yours.
Of course. Of course.
Gostou?
Mais pra frente você um pouquinho.
Ah,
É.
tá. Mas isso aqui
Sim,
é do seu.
sim.
Llenar. Sí, muchas gracias. Muchas gracias. ¿Este está activado? Okay. Our speaker, next speaker sets up. I would like to welcome everyone and to this next session. This is our platinum sponsor talk. And we're going to have Dr. Gennaro Costa here giving us a talk about exascale, HPCs, and its workloads. First of all, let me actually introduce myself as well. I'm Silvio Rizzi from Argonne National Lab. Really happy to be here, surrounded with friends and colleagues, and especially here in Santiago, which is close to my home city of Mendoza, Argentina, 5-hour drive to the east. And so let me quickly read a few or highlights from Dr. Costa's bio, which you can find online on the Carla webpage. So he works as an HPC distinguished expert at Eviden. He is also working in Senai Cimatech. He's an adjunct professor at UFBA. He holds a degree in computer science from UC Sal and a master's and doctorate in informatics from the Universitat Autónoma de Barcelona. With that, please come to the podium and take it away.
Hello, good morning. Thank you very much for the opportunity to talk to you all. Okay, here's a picture that few years ago, so I want to be reaching that soon. Okay, I'll be quickly on my presentation, and I try to bring here some information that could be nice for you to see how AI and HPC are going together, okay? And I try to bring some info, let's say, very nice information. I don't know if you are aware of this paper for Meta. It's a paper that, it's a technical report that was released about a few months ago that presents technical information about the training for the Llama model that is close to the GPT, is competing for the GPT. And there are very interesting information there that could help us to understand how HPC and AI are running, okay? The workload, it's about 405 billion parameters, so we would say the model size, it's about 800 gigabytes, but when you go for training, you have to scale this up. So if you're thinking about the computation needs, it's about 3.8 by 10 the power of 21. If you're thinking about 1 petaflop is 15, 1 exaflop is 18. So it's a huge need for computation. They use about 16,000 H100. The machine itself has 24,000 H100. Each H100 consumes close to one kilowatt one. So it will be a machine. If you run the top 500, it will be a top 5 machine. Okay, using the specs we have for our benchmark team. They use a very nice storage of 240 petabytes. And this is interesting. This storage has to provide about 2 terabytes per second of bandwidth. Okay. Another interesting fact is that they have a three-layer network, but the connection, they have no subscription in clusters for 3,000 GPUs, but those clusters are connected by 1.7 subscription. So the point is that when you train a very big model, you have the problem to face that if you have that size or that number of components, somehow your machine will fail. So they need to do a lot of checkpointing, and if the data is let's say a massive data set, you have to checkpoint a big chunk of data. So this is an interesting graph, an interesting table that comes from the work. This is the pre-training phase. Took about 54 days, and they have about 419 interruptions. Okay, so if you have a machine on that size, it's a machine that will fail. You will fail often, so you have to checkpoint often, so you don't lose your work. Okay, and the failure comes from many sources. There is the high-level failure, okay, from GPU, but you have even let's say when you have a lot of components, you may have fail of some hardware interruption, so the library doesn't work well, you have failed memory and everything else. You have these tables on the work, and very interesting to see that you have more than 1 failure per hour. So with that, we have to think about how can we have a system that can support this kind of workload. That's something that we may face on our HPC centers. So we have, this is, let's say, a resume. Okay. If you have a big workload, you have a big system to process it. Okay. When you go to a big system, when you raise the number of components of the system, you have to analyze the fail rate. So you will have a frequent component failure. So, but that rate can be actually, let's say, influenced, but with how you design the system. that's why we state here, okay? So we have a good system design. We can lower a little bit of the component failing. So how we can tolerate fail? You have to have frequent checkpointing. You have to save the data in the progress whenever you save the data in the progress. So you have to have a good network and also storage. That's my point. About good design, okay? Why we're talking about good design? Because I'm from Eviden, and Eviden is a spin-off from Atos, but we have roots on machine design and machine construction since Bull. In 1931, we started doing computing, and 2014, Bull was acquired by Atos, and we were Atos for a few years. And 2023, Atos became too big. You are a spin-off. It's called the Eviden. So here you have our degree. From our division, we still call us Boo. Okay, so we continue Boo. Our mission is giving an end-to-end solution, not only design the hardware, help you guys to maintain the software, the infrastructure, and also have an application. Have a center, for example, to have a parallelized application to run on those machines. Okay. What we've been done, we have providing the biggest machines in Europe. We are the biggest HPC provider in Latin America and India. And also we're selling many systems for the enterprise. Okay, we are seeing now that with the AI, the enterprise start buying HPC, start buying GPUs and high-speed network. Okay, for Latin America, we won most of the deals for Petrobras. So we design, we integrate, and we support those systems. Petrobras had double the capacity every year. The biggest machine running right now is Pegasus. It's based on H100. We are the support for LNCC. Okay, we'll talk about a bit about the new machine of LNCC, and also for Senai Cimatec. Okay, join Atos from university to open a research lab inside Senai Cimatec. Okay. Well, we are to reduce fail rate. We have to reduce the hardware stress. One source of stress is the heat. When you heat the component, you stress the component. If the component is stressed, you have a high probability of fail. If you go for these machines, Petrobras, it's all air-cooled. And air-cooled, you don't control exactly the heat of the GPUs. We have, let's say, a little bit high fail rate GPUs on Pegasus, and it's a 2000 GPU machine, okay? So we are dealing with this kind of cooling for a long time. The first generation, it was in 2014, is the one that we have on LNCC. LNCC have the second generation, the X1000. It was installed in 2019. We didn't have any H2000 in Brazil, and the next machine that will be arriving on LNCC will be a XH3000. This machine follows in some categories. When you analyze the different kinds of cooling, you can categorize in three types. Okay, the entry level is when you remove the heat only for CPU and GPU. The second level of DLC is when you have also the memory, you remove the heat for the memory. But you know that inside the machine there are components, like there are the power supply, okay, there are the disks, and even the chipset for the motherboard. So we have some machines that can remove the heat for all the components, even the network. That's called the advanced level HPC. If you compare who is providing those kinds of machine today, okay, we have Eviden. We can remove up to 95% of the heat using liquid cooling. We have our competitors here. The colors shows who they are. Okay, they are present here today. But that all impacts on the stability of the system, impacts on system that can raise to large number of GPU. about big machine, we are installing the machine Jupyter on Jülich. This is the first exascale machines. It's a machine with 20,000 GPUs that be installed in 125 hex. It's interesting because this machine will be a completely ARM-based machine. Both the CPUs that are serving the GPUs and also the CPU nodes are based on ARM ones. The first model of this machine were run on the supercomputer last year and is the most power efficient machine. Okay, you're facing here is a model. You have here that red one is the hack that's running the X3000. Okay, we can handle up to 8 GPUs H100 in 1 unit of rack. If you compare to NVIDIA that have 10 U's, okay, you are 10 times more more efficient and save space without any mechanical inside the blade. But we also support the accelerators for AMD. We can handle 6 APUs inside 1 unit of rack. Of course, both blades have the network needed to connect it. So you have one link for each accelerator to both handle the checkpointing and both handle the communication need between the GPUs. Both of those blades will be available on LNCC. LNCC had an upgrade that will be installed by the end of the year. Okay, we'd expect to be running before of the end of the year. Okay, and we have a partition with CPU partition. Very interesting because the CPU partition for LNCC will have the high bandwidth memory. That was a memory that comes from the GPU. We'll have a partition with Intel and NVIDIA GPUs, and we have a partition with the Grace Hopper that is an NVIDIA GPU and CPU, and you can also have a small partition we're using the AMD nodes. Okay, something interesting that it's interesting that we have our software and our a very nice implementation for the storage. We do our traditional information, but we also have some implementation use the NVIDIA hardware. We have a very nice installation in Ecuador and also in Banco do Brasil using NVIDIA hardware. About the storage, DDN is our partner today. A big partner today is the one that was chosen by NVIDIA to run on their machine. So all the machines from NVIDIA runs on DDN storage. When you go to AI, you have to save your checkpoint frequently. But what the impact on the training? Okay, you can have about 6% impact on the loading and about 45% impact on checkpointing. So we have to think about if you have one GPU, what the bandwidth should I have to handle one GPU? If you have one GPU with 80 gigabytes of memory, and you have to save the data, and you have 1 gigabyte per second, you have 80 seconds just to save the data for one GPU. And that is not only to save you for head start, but checkpointing is the part for machine learning, because you use the checkpoint to get back to a moment when you have better, let's say, statistical established, so you can do a better training in going to different direction. So that is the checkpointing is using in the pipeline for network training. Okay, this is a solution for DDN. You can handle for 2U up to 90 gigabytes per second. Information about this device is that the limitation here is not the velocity of the disks. The limitation for the system is the velocity of the memory. Okay, so they are very, very efficient. They have about 8 connections of NDR200. The next version will double those numbers. So we can think that it will be launched on supercomputing in a few months, okay? So when you're thinking about scale the machine, you have to scale up the performance. With less than 1 hack, we can go close to 1 terabyte per second. If you go to measure the architecture, that's the map between the number of GPUs and the number of systems that you need to train the model, okay? So, for example, if you go to one machine with 8 GPUs, you can think that your need will be about 8 gigabytes per second, okay? But if you go to a bigger machine, like 32 DGX, okay? Perhaps you need about 36 gigabytes per second to handle a good training, okay? Why this number, 32? Because if you drop the precision, 32 DGX is an exaflop machine. Okay? It's a FP 8 bits exaflop machine. So you have those numbers, and you have to scale up and also take care about the locality for this running. So if you go to 4 times this, you have 1,000 GPUs is half about the bid for Petrobras, okay? And you need more than 1 terabyte per second machine. So just finishing. That's the message is just repeating, because take care about the system design, because the heat stabilization will have a huge impact on GPU failure, okay? So if you can, you should start with DLC. You should start with liquid cooling right on the way, so you lower the stress on the hardware, okay? You should think about the network. The network is very important, not only to do the parallelization, but to also save the data. So at least one link per GPU. Don't do subscription, so the good network design will impact on the time. And thinking about also about the storage, because without the storage, you have a very good machine, but you have a very poor machine utilization. That's it. That's my main. Thank you very much. Okay.
Would you like to invite questions from the audience?
Well, if you have some questions.
Yeah.
Yes.
Let's use the mic here.
All right, thank you very much for your talk, Gennaro. So when you talk to a customer and you're trying to sell a machine, so you usually have to talk about the specs of the machine, right? And for some applications, it's more important to have more CPUs or more memory or a better I/O, right? So can you share with us your experience when dealing with people that do large language models? What sort of specs they are looking for, and if they use some benchmarks to measure if your machine is proper for their work?
Thanks for the question. When you go with large language model, you have to do pass of the data quickly, okay? And we have not a data sheet, but a technical work done by DDN, okay, showing that if you don't do the checkpointing fast, you lose GPU time. The GPU time is very expensive today, okay? So generally you have to have this kind of technology, GPU direct storage. Generally when they start to dealing with the training, the GPU direct storage allow you for GPUs to save directly to the storage without using the CPUs. So it's very fast to doing that. So if you have this kind of technology, you can speed up the parallelism accessing the storage and also integrate the storage as the part of the training. That's this benchmark. They ask, hey, how do you do as GPU direct storage? That is the main characteristic, okay?
We have 30 more seconds for one more quick question. And if not, let's thank our speaker once again.
Thank you very much for the opportunity.
Thank you.
Hola, buenos días a todos. Es un momento muy especial porque no siempre tenemos a personalidades como las que vamos a tener hoy aquí en este panel. Este panel va a ser un panel bilingüe. It's going to be a bilingual panel. Whoever wants to speak in English, it's free to do so. And whoever wants to speak in Spanish can speak in Spanish. Or Portuguese, yes. El panel que hoy nos reúne a representantes de distintas organizaciones que están dedicadas al financiamiento de proyectos no solo en nuestra región, sino en varias regiones del mundo, y hemos querido hacer este panel para poder acercar a la comunidad de cómputo de alto desempeño con estos actores relevantes como son el Banco Mundial, el Banco Interamericano de Desarrollo, siempre se me olvida el nombre de CAF, ¿cómo decirlo? El Banco de Desarrollo de América Latina y el Caribe, y la Unión Europea, que en realidad no es un banco, sino es un todavía, sino ha sido una organización que ha tenido una vinculación muy cercana con América Latina para el financiamiento de proyectos de gran alcance para ambas regiones. Y además tenemos en particular, and I'm going to switch to English so Fabricio understands better, we have an opportunity to get a very close experience of what a project being financed by the European community was able to do in Europe and Latin America with regards to HPC. So les doy la bienvenida, ahorita los voy a presentar a cada uno, pero me gustaría no perder tanto tiempo en leer sus semblanzas. Creo que ustedes las pueden ver en el website. Solo voy a decir quiénes nos están acompañando hoy. Es Fabricio Gigliardi del Barcelona Supercomputing Center con el proyecto RISC-2. Nos acompaña también Marcelo Facchina del Development Bank of Latin America and the Caribbean. Es que el CAF que conocemos todos. Fernando Vargas de Inter-American Development Bank. Axel Rifón Pérez, Senior Digital Development Specialist del World Bank Group. Francisco García García, Head of Cooperation at the Delegation of the European Union in Chile, y le felicitamos porque está recién ocupando este puesto. Recién llegado, exacto, es que… Y también quisiera decirles, este panel, como los paneles anteriores, fue organizado por dos personas. En este caso no nos puede acompañar hoy José Palacios de Reúna, pero él estuvo involucrado en la organización de este panel. Bueno, ya habiendo dicho eso, solo les quiero mencionar que el objetivo principal de este panel fue que fomentáramos la colaboración y el desarrollo de infraestructura de cómputo de alto desempeño en América Latina y el Caribe a través de la identificación y exploración de diversas fuentes de financiamiento. Entonces, para ello yo les voy a dar un espacio de 8 minutos a cada uno. Ellos tienen algunas preguntas que yo les expuse cuando los invitamos y nos van a contar sobre su organización y los proyectos que han hecho de colaboración, sobre todo porque en este caso está enfocado el panel a una acción colaborativa de varios países para desarrollar regionalmente una infraestructura de HPC que sirva a todos los investigadores de la región. Entonces, con ese motivo, yo le voy a dar la palabra en primer lugar al representante del Banco Interamericano de Desarrollo para que tome sus 8 minutos.
Well, thank you so much, and I'm gonna thanks also personally to the organizers. It has been a really great pleasure for me to come to the conference, to engage with the community. I don't know if someone can put the slides over there that I have, please. Well, here at the bank, we have been working with the scientific and technology community for years in the Latin American and the Caribbean region, and we have engaged with many of you, particularly in specific projects. But my hunch from the very first 2 days in the conference has been that I think I need to explain a little bit more about how who we are and what we do and how we can collaborate to increase, in this case, the availability of high-performance computing for the research community in Latin America and the Caribbean. So I have a short video because it's way better than my short explanation of what we do. So I'm going to play just a very short introductory video on the general view of what we do, and then talk a little bit more specifically on what we have done and what we can do. Not yet? I think it's, yes. All right, thank you. So I'll switch this, and should work now, right? Sorry, can you just play the video, please? Yeah. I know which one is the one that. So in the meantime then, while they solve the video, I will start saying that we are a group. We have 3 institutions within the IDB group. We have the, let's say, more traditional one, and the IDB side where I work. Okay, I think the video is, okay, we can just play it in. No, maybe they can do it because I don't want to. All right, well, short video introduction of the IDB.
We are the Inter-American Development Bank Group, a multilateral institution created to improve lives in Latin America and the Caribbean. For more than 6 decades, we have been the leading development lender, the region's trusted partner in reducing poverty, advancing health and education, investing in physical and digital infrastructure, creating jobs and addressing climate change, and so much more. The IDB achieves this by working with the public sector. The IDB Invest does it working with the private sector. An IDB Lab provides innovation and venture capital. Together, we deliver a wealth of knowledge, technical support, and more than $24 billion in financing and resource mobilization every year, backed by our AAA credit rating that allows us to borrow and lend at competitive rates. This is due also to our broad membership located around the globe, with 48 member countries, 26 in the region and 22 in North America, Europe, and Asia. But our region is at a crossroads, facing rising social demands, scarce fiscal resources to serve them, and low growth. Climate change is a real problem, not only in Latin America and the Caribbean, but around the world. That's why at the IDB Group, we aim higher. We know that the region can be a solution for these global challenges, including addressing food insecurity, nature, and biodiversity preservation. The IDB Group is the bridge that connects these solutions with the rest of the world. The region is potentially at an inflection point. We are working at the IDB Group to help the region seize this opportunity, and that's why we're implementing 3 transformational changes under the initiative IDB Impact Plus. They include IDB Strategy Plus, a new strategy for the IDB Group with 3 core objectives: reducing poverty and inequality, addressing climate change, bolstering sustainable growth. IDB Invest Plus has a new business model and a fresh injection of capital of $3.5 billion. And IDB Lab Plus has a more scalable approach to promote innovation with an additional $400 million in resources. At the IDB Group, we define our success not by the dollars we lend, but by the results we achieve. Less poverty, less inequality, more clean energy, more jobs. That's how we impact the people in Latin America and the Caribbean at a larger scale, and by extension, the world.
Well, thank you. And if you can go back to the slides, please. So, as we were saying at the end of the video, we are driven by results, and our results need to be connected to the priorities that we have defined. We have these 3 institutions within the group, and we are all aiming into the same direction, to have economic impact in our region that allow us to decrease poverty and inequality, to be better prepared to climate change, and to spur sustainable economic growth in our economies. So we are the Competitiveness, Technology and Innovation Division. We do that working with countries, specifically on the public sector, to develop and implement policies that allow for the development of the private sector driven by innovation and knowledge. We do this increasing research capacities in our countries, strengthening the scientific and technological infrastructure, allowing countries to have a very rich innovation policy portfolio, and strengthening, of course, the capacities of the public sector that is in charge of designing, implementing, and evaluating these policies. So this sounds, I know, like a little bit general, so I want to show you a few examples on how we implement this with our country members and how these connect with the high-performance computing. For instance, this is an example of a program in Argentina where we invest together around $1,200 million between 2009 and 2022, working specifically on improving business productivity and increasing investment in R&D in the country. One of the components of this program, of this series of programs actually, was to strengthening specific scientific and technological capabilities with around 23% of those resources. And what we did in that was to allow to dedicate some money for research projects with the scientific community, but also to strengthen the infrastructure and the equipment available in the country to conduct this research. So we increased the supply of these inputs that were necessary for science and technology in the country. There is a specific line which is the financing of large scientific facilities where the high-performance computing network of the country lives and get financing not only for investments but also on the maintenance of the system and let's say work with the current expenditures on that line. So we did that very successfully in the last 10 to 15 years. We currently have another program running right now with 220 million that maintains this 25% of resources allocation to large scientific facilities. And we're pretty sure that with the current, I don't want to call it hype, but renewed interest on artificial intelligence, that number should go up in the case of Argentina. And in Uruguay, considering the scale, it was also an ambitious program with the same idea, to increase private sector investment in innovation and technological adoption. And to achieve that, we needed to work with the local scientific and research communities. Part of that investment, again, went to increasing the generation of scientific and technological knowledge through strengthening the scientific equipment program, where the very first equipments of the the cluster of supercomputing of Uruguay got their first equipments working there, and were being at the beginning of this program with the Universidad de la República, University of Republic, and we have another program currently that is again dedicated more or less the same amount, relative amount of investment to strengthening the high performance computing access for the country. So this is more or less how we transform these objectives of impacting at the economic development of a country through science, technology, and innovation. But in the work with the AI, or this new AI intercept that the world is doing, we see an opportunity for change of the region. We see an opportunity for leapfrogging, not only on the scientific side, but on the productive side. We are trying to work at the very basic level, in the sense of not telling the countries what they exactly need to do in terms of the technological progress, but to help them to increase, to improve actually the conditions in the country for more and more development on AI locally, and to adapt what is being done at the global scale. We think this is important because this is a general purpose technology that will impact every aspect of the economy, potentially at least, and particularly because we think that this is a new way of inventing things. In many scientific fields, and you know this better than me, you're going to get faster and probably higher quality potential hypotheses for development of new materials or new compounds, as we're seeing now in pharma, for instance. So we need to provide the countries of the region with this capacity. With this capacity in place, we can increase our innovation rate and then pursue the sustainable economic growth. We do this because we know that this adoption and development is not automatic at all. We need these capabilities, and we need these public goods, but also we need to deal with the risk and unintended consequences, as we were hearing yesterday from the talk of Ulises, I believe. So we're working on these three priorities for this initiative. And just to wrap up, one of the key aspects of our new AI strategy is to improve data and infrastructure for AI. That means working with the private sector and with the public sector to increase availability of data centers, promoting data sharing ecosystems, access to HPC, and improve our connectivity. Our countries have still like a significant lag on that, and we need to work together into this. I'm not going to go more than that, but thank you so much, and of course, we remain open to the rest of the panel.
Gracias, Fernando. No voy a hacer preguntas ahorita, vamos a hacerlas hacia el final. Le voy a pasar la palabra a Marcelo de CAF para que nos haga un resumen de lo que ellos están proponiendo.
Dale, bueno, muchas gracias Salma. Es un placer estar acá. Bueno, for the sake of the bilingualism of this panel, I'm going to do my presentation in Spanish, okay? But if you feel that there's any clarification that must be done, please feel free to reach out in English as well, o en portugués. Bueno, ahí hablamos bueno, los idiomas de la región acá en CAF, el Banco de Desarrollo de América Latina. No sé si mi presentación también está ahí en el pipeline, pero antes que, bueno, ya para aprovechando el tiempo también y sabiendo que vamos cortos porque tenemos un panel de lujo, pero bastante grande también, les comento que soy ejecutivo principal de la Dirección de Transformación Digital de CAF, que es parte de la Gerencia de Infraestructura Física y Transformación Digital. Estoy basado en Santiago de Chile y también creo que es importante comentar, ¿no?, que CAF, en cuanto a Banco de Desarrollo, también tiene una presencia extensiva en la región. Diferentemente del BID del Banco Mundial, este es un banco de desarrollo que no tiene países donantes. Los 23 países que hacen parte de la institución, incluyendo Portugal y España, son también países prestatarios de los recursos que CAF dispone para el financiamiento del desarrollo en varias áreas, ¿no? Pero de todas formas, el enfoque principal, por supuesto, del banco está efectivamente en la región de la América Latina y el Caribe. Y para aquellos que encuentran una cierta disonancia entre lo que tenemos como el acrónimo y el título, simplemente les comento que antes CAF era la Corporación Andina de Fomento. O sea, es un banco que nació dentro de los países andinos, pero a lo largo de los años se ha expandido para toda la región. Y hoy les quería comentar un poco sobre cómo vemos el tema del panorama del desarrollo digital en la región. y también, claro, las oportunidades que HPCs pueden ofrecer para que busquemos cada vez más y siempre y cuando podamos cerrar las brechas en relación a los países más desarrollados en lo que concierne el tema del desarrollo digital. No sé por qué razón eso no está avanzando. Tú que tuviste como tu primera experiencia ahí. Okay. So, this guy, how do I switch slides here? Okay, no, now we're good. Sí. Okay, nice. Bueno, entonces la agenda de transformación digital de CAF, como les comenté, bueno, tiene ahí como objetivo principal el tema de promover una cultura de innovación digital en la región a través de financiamiento y conocimiento accionable. O sea, ahí queremos pasar más bien de apenas ser un banco en que apoya financieramente lo que son los proyectos, sino que ser efectivamente un socio en el desarrollo de esas políticas públicas y esas iniciativas, a través también de la asistencia técnica, ¿no? Pero sobre todo el despliegue de infraestructura digital para finalmente poder utilizar tecnologías digitales emergentes para promover el desarrollo de hogares, gobiernos y los sectores productivos de la región. Porque en verdad lo que vemos como el panorama general es que en cuanto a región no vamos muy bien, ¿no? Si tomamos los datos de nuestro Observatorio de Desarrollo del Ecosistema Digital, observamos que si bien tenemos ahí el 13% de la población mundial, el nivel de desarrollo a nivel general de América Latina en relación a temas digitales es, bueno, simplemente apenas superior a lo que es de la África subsahariana. En relación a todas las otras regiones del mundo, de verdad vamos atrás. Y importante mencionar que además que de un rezago histórico, lo que tenemos es un rezago persistente. O sea, vamos avanzando, vamos haciendo inversiones. Fernando ya comentó varias iniciativas muy interesantes relacionadas a la promoción de un ecosistema digital más saludable, pero en verdad el nivel de inversión que estamos haciendo está muy por debajo de lo que se necesita efectivamente para promover lo que es esta convergencia en relación a lo que son los países más desarrollados. Y parte del trabajo de los bancos de desarrollo y de CAF también en particular es buscar achicar esta brecha, ¿no? A través, por ejemplo, de temas como infraestructuras digitales un poco más básicas, como el tema de la universalización del acceso a banda ancha, el despliegue de infraestructuras, ¿no?, de alta velocidad, la promoción de digitalización de ecosistemas productivos, pero también trabajando con toda esa agenda de tecnologías disruptivas y emergentes que también posicionan a Latinoamérica y promueven el desarrollo digital, aunque eso no produzca necesariamente lo que es el trabajo de convergencia. Y si miramos, ¿no?, efectivamente en términos de brechas, si vamos ya rezagados cuando hablamos en temas de infraestructuras digitales más básicas, cuando hablamos de tecnologías digitales 4.0, eso se verifica de igual manera, ¿no? Entonces ahí si comparamos efectivamente los índices de relación dentro de nuestro índice de desarrollo del ecosistema digital en temas relacionados a Big Data, a la utilización de data centers, a inversiones en cloud y a inversiones en Internet de las Cosas, efectivamente vemos que la brecha tiene una tendencia incluso de ampliarse, ¿no? Pero se nota efectivamente que la demanda por financiamiento digital está en crecimiento en la región, ¿no? Si tomamos simplemente lo que es la gerencia de infraestructura física y transformación digital de CAF, dentro de la cual tenemos esa dirección de transformación digital, hemos notado que pasamos entre 2010 y 2015 de un portafolio que alcanzaba como máximo unos 500 millones de dólares, ya llegamos para el 2024 a casi 5.000 millones de dólares, o sea, en un espacio de tiempo relativamente corto se nota una explosión de esta demanda de parte de los gobiernos y de nuestras contrapartes en general. Cabe mencionar que CAF también tiene un brazo no soberano, pero no es una institución apartada de CAF, como es el caso, por ejemplo, del BID y del Banco Mundial. De hecho, eso es parte de la misma estructura que tenemos dentro de la organización. Y ahí es interesante también mencionar que los tipos de préstamos que se puedan pensar a nivel de promoción de desarrollo digital tocan tanto los temas relacionados a el desarrollo de infraestructuras, pero también las reformas de política necesarias al desarrollo y a puesta en valor de lo que son esas infraestructuras a nivel nacional. Ahora entrando un poco más en lo cuales son los desafíos y oportunidades de América Latina, ya más bien en el mundo del supercómputo. Aquí, la verdad, estoy preaching for experts, entonces no creo que haya mucho más que añadir, pero de todas formas sabemos, ¿no?, que tenemos ahí una baja participación a nivel global, algo alrededor de los 2% en términos de capacidad de cómputo, ¿no?, una alta concentración de ese elemento en algunos pocos países, ¿no?, una bajísima participación en lo que es la generación de la cadena de valor alrededor de todo lo que son los HPCs, y desafíos, ¿no?, relacionados sobre todo a lo que son las infraestructuras habilitantes, ¿no?, dentro del ecosistema. En la presentación anterior a este panel se había comentado también los temas relacionados, por ejemplo, a storage y otras cosas, y de hecho, ¿no?, como tenemos desafíos relacionados a instalación de data centers, a la calidad de nuestra infraestructura de conectividad, aunque la penetración haya crecido de manera sustancial en los últimos años, y esos desafíos sí siguen persistentes, ¿no? Pero claro, también hay buenas noticias, ¿no? Tenemos una demanda en crecimiento, como había comentado, los aspectos, ¿no?, y todos los temas asociados a geopolítica de la tecnología permite que Latinoamérica se posicione en un lugar que puede ser de utilidad para, sobre todo, lo que es el avance de ese tipo de desarrollo dentro de la región en una cadena de valor un poco más acercada, y por eso las oportunidades de nearshoring. Es una región con una alta disponibilidad energética limpia y capacidades de resfriamiento también de esas máquinas, que es súper importante, y también es una oportunidad, ¿no? La inversión en ese tipo de infraestructuras también puede apoyar todo el trabajo y todos los beneficios que puede generar un abordaje de mayor soberanía tecnológica de la región en ese contexto geopolítico cambiante y conflictivo. Y bueno, ¿y qué CAF está haciendo entonces para cerrar esa brecha? Uno de los ejemplos de estudios y trabajos que estamos haciendo es efectivamente el estudio de prefactibilidad para diseños de proyectos de centros de computación de alto rendimiento, con énfasis en inteligencia artificial, pero también en otras aplicaciones en la región, ¿no? Y ahí con un enfoque especial en Chile y en República Dominicana, pero también buscando que eso se expanda a otros países de la región, y siempre con ese enfoque y esa ancla en lo que es el tema de la promoción del desarrollo digital. O sea, estamos aquí también sobre todo trabajando con temas relacionados a investigación científica, pero pensando también en lo que es la promoción de un ciclo completo de desarrollo y hacer efectivamente que movamos la aguja del bienestar de las personas, ¿no?, y del medio ambiente en la región. Y ahí por esa razón trabajando con temas de fortalecimiento de las capacidades tecnológicas. En ese contexto del estudio de prefactibilidad también vamos a hacer un levantamiento muy detallado de las capacidades existentes tanto a nivel público como privado en la región, o análisis del potencial impacto de HPCs para usos generales, y ahí con un enfoque especial en la inteligencia artificial, también por la demanda de los gobiernos, en especial Chile, asociado a eso, ¿no? Buscar entender efectivamente cuál es la proyección de demanda futura para HPCs en la región y aterrizar eso a nivel de hojas de ruta de desarrollo que tocan los temas de HPCs, pero la política pública de manera general para Chile y República Dominicana, y ojalá algunos otros países, ¿no? Y bueno, ahí notamos un ciclo de proyecto de 8 meses con aplicaciones efectivamente en temas de salud, agricultura, movilidad, ciudades inteligentes, cambio climático y también el desarrollo de industrias. También estamos trabajando de manera muy fuerte en todo lo que son las infraestructuras que habilitan un mejor ecosistema relacionado a eso. Destacaría aquí temas relacionados a cables submarinos, ¿no?, para que efectivamente también asociado a lo que es esa discusión de la soberanía tecnológica de la región. Y simplemente aquí comentando en palabras finales, porque sé que el tiempo está corto, bueno, el papel de CAF también, entonces, en cuanto a Banco de Desarrollo, es efectivamente apoyar, ¿no?, que ese crecimiento de la demanda de inversión siga acelerada y siga generando impactos importantes para lo que es el desarrollo digital, ¿no? Pero es muy claro que la capacidad de los bancos de desarrollo para promover, ¿no?, ese trabajo en dirección a la convergencia que había comentado con regiones más desarrolladas es limitada, y por eso también el abordaje de política pública que hago tanto refuerzo acá. A mí me parece que Banco de Desarrollo de manera general tiene esa potestad y ese interesante mecanismo de tener un acercamiento continuo con gobiernos y una capacidad de alinear objetivos entre distintos actores del ecosistema para llegar a ese tipo de resultado y de impacto, ¿no? Y también con una capacidad de inversión para el apoyo a políticas públicas y a esas infraestructuras habilitantes, como les comenté, ¿no? Y ahí llegando a un impacto concreto a la vida de las personas. Pero eso, ¿no?, siempre con ese enfoque de generación de evidencias también para maximizar el impacto del desarrollo de todo lo que son los trabajos que hacemos. Corto por aquí. Muchas gracias.
Muchísimas gracias. Ahora le voy a dar la palabra a Axel Rifón para que nos cuentes la visión de Banco Mundial.
No tengo presentación. Buenos días a todos, muchas gracias. Creo que me han facilitado la tarea a mis colegas Fernando y Marcelo porque ya han resumido mucho de lo que hacen los bancos de desarrollo. Igual algunas diferencias. El Banco Mundial, al final, como indica su nombre, tiene un footprint en varias regiones. Eso nos permite también movilizar una serie de conocimientos, una serie de recursos en otras regiones. Y, desgraciadamente, como ha mencionado Marcelo, la región de América Latina está un poco más atrás que otras regiones, entonces es importante traer estas experiencias de regiones como sudeste asiático o la Europa y otras regiones en el desarrollo de habilidades digitales, en el desarrollo de la infraestructura para poder lograr lo que buscamos todos, que es un desarrollo digital inclusivo que permita cerrar estas brechas. Ahondar también un poco en los productos, son muy similares. Creo que es muy importante aquí, en este caso, la movilización del sector privado. Hemos visto en la presentación del doctor Acosta casi todos los sponsors, casi todos los HPCs tienen la participación del sector privado y creemos que los bancos de desarrollo, los bancos multilaterales, tienen ese deber de facilitar esa participación. No se va a lograr con financiación pública cerrar estas brechas, lograr la inclusión tanto en habilidades como en tema de infraestructura de datos. El otro día había un dato que publicaron unos informes en el banco que California tenía más capacidad de infraestructura de datos que toda África subsahariana. Estas brechas son enormes. También la región de América Latina, en otro informe de la OCDE, decían que tenía casi menos del 10% que los demás países de la OCDE. Y obviamente en población y en aspectos tendría que tener muchísima más capacidad de procesamiento de datos y también poder desarrollar estas sinergias. Yendo a un caso concreto, el Banco Mundial está financiando un proyecto, se llama Fortalecimiento de la Infraestructura Digital para el cierre de la brecha en Argentina. De hecho, hemos venido trabajando con CAF y con BID para apoyar al gobierno de Argentina, que tomó en la administración anterior y en esta administración un enfoque muy importante sobre fortalecer la infraestructura de datos, cerrar las brechas con las diferentes RFEFOS, las redes dorsales y otras, y trabajando con partners como ARSAT, el Instituto Balseiro y otros. Uno de los puntos que hemos visto en la financiación de estos proyectos es la importancia de tener no solo infraestructura, como dicen, en fierros, sino también en habilidades digitales. Entonces, en todos los proyectos que está financiando el banco hay un componente de habilidades digitales que varía entre un 5 y 10% de la inversión. Estamos hablando de unos 200 millones para Argentina, tenemos casi 10 millones de dólares dedicados exclusivamente a la formación de habilidades. ¿Por qué digo eso? En uno de los informes que me parece que el BID hizo en colaboración también con la ITU, donde también estuvo Salma, se mencionaba que en torno a solo 10% de los países de América Latina tienen una población que sea más del 15% en habilidades avanzadas. Aquí vemos una audiencia muy sofisticada, vemos todo un ecosistema muy desarrollado de academia, de científicos. La realidad es que la mayoría de la población carece casi de las habilidades digitales básicas. Creo que el 70% de la población de América Latina no tiene esas habilidades. Por ende, no tienen un acceso a los beneficios de la transformación digital y, por ende, también el acceso a servicios públicos y otros temas. Y, finalmente, lo ha mencionado también mi colega Marcelo, importante también una transformación digital que pueda contribuir a los objetivos de desarrollo sostenible y también a la lucha contra el cambio climático. En ese caso, el banco publicó un informe sobre los datacentros verdes y una metodología con el IFC, que es el equivalente al partner privado del BID Invest, en el caso del BID, sobre cómo se puede hacer inversiones en centros de datos verdes y sostenibles, y una serie de metodología y una certificación EDGE, que es la que se está tomando ahora y la que viene obligatoriamente las diferentes financiaciones que está haciendo el banco en centros de datos. En resumen, creemos que hay 4 factores que son importantes. Lo primero, la movilización del sector privado y del ecosistema, trabajando con universidades, con académicos, pero sobre todo apoyando también en un marco regulador que habilite estas inversiones. También lo han mencionado mis colegas, en muchos países hay leyes, regulaciones que impiden esa inversión, lo cual impide este desarrollo digital inclusivo. Segundo, tener en cuenta que hay una serie de prerequisitos relacionados con el desarrollo digital, las habilidades, la infraestructura inclusiva. Sabemos que al final ni la mitad de los hogares en América Latina tiene acceso a banda ancha. Datos de la ITU, GSMA en todas sus conferencias, por ejemplo en el último foro GSMA de México. Entonces hay todavía una inversión necesaria y una necesidad de inversión pública que puede venir complementada con financiación de bancos de desarrollo como los que estamos aquí sentados. Tercer punto, el contexto local es muy importante. Vemos, por ejemplo, que Chile me parece que a nivel de habilidades avanzadas es de los más desarrollados de América Latina, al nivel casi de Noruega. Con lo cual hay, como dicen, brotes verdes. Creemos que hay que tratar de sembrar en esos brotes, tratar de hacer más cooperación regional. Vemos que hay pocas iniciativas de integración regional. La comunidad andina, donde también estaba CAF, es una de ellas que podemos creer que se podría ampliar con iniciativas como el roaming y otras iniciativas que podrían ayudar un poco a este desarrollo general de la región en el tema de la economía digital. Y finalmente, estos foros, estos intercambios, tratar de buscar partners y de ver cómo podemos responder a las demandas de los gobiernos y también facilitar las inversiones del sector privado. Muchas gracias.
Muchas gracias. Tenemos ahora a Francisco García de la Unión Europea.
Paco.
Adelante.
Muchas gracias. Bueno, primero agradecer, este es mi primer evento público desde que llegué a Chile, así que es un honor y un placer estar aquí con vosotros hoy. Agradecer a nuestros socios en Chile de la Alianza Digital, que son Red Clara y el Centro de Modelamiento Matemático de la Universidad, que cooperan con nosotros en el satélite Copérnicos. Gracias, porque si no mi primer evento hubiera sido algo de finanzas públicas o algo aburrido. A mí me impresiona un poco estar aquí entre expertos. Yo era un friki de la informática de pequeñito, programaba ZX Spectrums y cosas así, luego la tecnología me superó y me hice burócrata y funcionario y acabé así. Entonces, bueno, como habéis dicho, no somos un banco. La Unión Europea no es un banco, a veces lo parece. Con España nos han cambiado el país entero. Con mi compatriota murciano tenemos ahora una carretera para ir a mi apartamento en la playa que la ha pagado Europa, pero no es un banco, pero sí tenemos un banco. Tenemos el Banco Europeo de Inversiones. Cuando yo hablo con mis hermanos de bancos, de lo que hago, de a qué me dedico, si tú le mencionas el Banco Mundial o el BID o incluso la CAF, tengo muchos amigos en la CAF, todo el mundo las conoce. Cuando les dices el BEI, dice el ¿qué? El Banco Europeo de Inversiones, como ellos dicen, es un banco muy grande que presta tanto como el Banco Mundial, o como la CAF, o como el BID, juntos. Lo que pasa es que prestan el 90% de lo que prestan en Europa. Entonces, nadie les conoce. Ni siquiera los europeos, cuando hacen la carretera, tú sabes que lo ha hecho el BEI, eso es la Unión Europea. Pero sí prestan un 10% fuera de Europa para cooperación y estamos muy activos con ellos trabajando en la Global Gateway, que ahora hablaremos. Entonces, bueno, como buen político de la Unión Europea, además de agradecer a Red Clara y a la universidad, al Centro Matemático, tengo que agradecer a mis colegas que llevan la Alianza Digital de la Unión Europea y América Latina y el Caribe en Bruselas. Se llaman Silvia, Gracia y Claudia. Y me están mandando WhatsApp. Me dice, Paco, es la última vez que participas en un panel de digital donde solo seáis hombres. Y me ha dicho, te vas a poner un sello aquí que diga mujeres y STEM, porque es algo, yo fui jefe de sector de género en Bruselas, entonces lo tengo en el corazón, así que queda para, for the record. Bueno, ahora en serio, Salma me persiguió por todos los aeropuertos del mundo mientras yo venía aquí para pedirme mi currículum, porque lo necesito, porque pago. Al final conseguí mandarlo antes de ayer y no lo has usado. Entonces, he perdido mi trabajo. Está por ahí, pero no, solo para deciros, antes de estar aquí en Chile hablando de computadoras y de supercomputadoras y de satélites, fui jefe de cooperación en Colombia, donde hacía el proceso de paz con las FARC. Fui jefe de cooperación en Bolivia, donde trabajaba con la CAF en la reducción de hoja de coca. Fui jefe de cooperación en Mozambique, donde hacía food security, es decir, yo esto de computers no sé nada, los funcionarios europeos sabemos de todo, un poco de nada. La que sabe es Pía, que está aquí conmigo, que es una mujer también, la que lleva todo el tema digital en la Unión Europea. Y acabo de llegar, entonces todo lo que diga, cogerlo con pinzas. Pero bueno, no tenemos un banco, pero sí trabajamos con todos los bancos, con el BID, con la CAF. El segundo día de llegar aquí me reuní con el jefe de la CAF porque teníamos que hablar con mi jefe en Bruselas y teníamos que preparar qué íbamos a decir. Y la Unión Europea se ha embarcado en una cosa que se llama Global Gateway, con la cooperación que nadie sabe lo que es, ni nuestros propios Estados miembros. Tengo que ir la semana que viene a explicarle a España, a Alemania, qué estamos haciendo con su dinero, que es la Global Gateway. Pero básicamente parte del convencimiento de que el dinero que nosotros tenemos en subvenciones para cooperación no es suficiente para lo que queremos hacer y no vamos a llegar a los SDGs que mencionaba Axel, porque el dinero de la cooperación es muy poquito, sobre todo en Chile, que es un país rico, donde el dinero de la cooperación es cero. Yo tengo algo de regional que pido, medio milloncito aquí, un milloncito. Estos señores hablan de 200, 300, como si... Entonces, con el Banco Europeo de Inversiones sí conseguimos eso, hablar de 7.000 millones o de 100. Y lo que trata es de decir, ok, yo en lugar de usar mi proyecto para hacer un proyectito pequeño, entonces yo tengo 1 millón para digital. Bueno, yo puedo darle el dinero a cualquier organización, a Naciones Unidas o con cualquiera de ellos, hacer una asistencia técnica, acaba mi millón, me voy. Yo no, ok, usemos el millón para convencer al Banco Mundial y a la CAF, es decir, ¿por qué no hacemos un fondo de inversión? Con mi millón pagamos al director y las oficinas, ustedes prestan al fondo y con ese fondo invertimos en supercomputadores o en satélites o en hidrógeno verde que estamos haciendo. Esa es la idea. Y entonces está el dinero de los bancos de desarrollo que se pone junto a los nuestros, pero una vez que tienes eso puedes empezar a traer dinero del sector privado. Entonces en el hidrógeno verde, pues podemos traer a un fondo de pensiones sueco y decir, oiga, tenemos esto aquí, usted va a ganar dinero porque lo que perdamos lo perdemos nosotros, usted pone su dinero ahí, las cosas de hidrógeno verde o de supercomputación que vayan bien, usted cobra los dividendos y las que pierda no se preocupe que las perdemos nosotros. Bueno, esa es la idea de Global Gateway. Entonces, una de las claves de Global Gateway, aparte del hidrógeno, del litio, de esas cosas, es lo digital. La Global Gateway se basa sobre todo en 2 cosas en las que Europa cree y quiere impulsar en el mundo. Una es la transición verde justa, todo el tema de las nuevas energías, reducción de CO2, y otra es la transición digital justa. Entonces, por decirlo así muy simple, cuando hablo con mi primo y le hablo de digital, digo, hay 3 modelos en el mundo grandes. Uno es el modelo americano, con grandes multinacionales, que es el que triunfa, y hay que reconocerlo, y es Google. Otro es el modelo chino, que se basa en otras cosas, y otro es el modelo que Europa trata de insertar en Europa, que se basa más en poner al ser humano en el centro de todo, en los derechos del ser humano, también en lo digital, en la confidencialidad, bueno, todas esas cosas muy duras que estamos poniendo los europeos cuando salen y le ponen multas a Google o a no sé quién por abuso de la competencia y porque mandan nuestros datos a empresas americanas, a servidores americanos, y eso no se puede. Y ahora llega la inteligencia artificial que lo va a cambiar todo. O sea, yo cuando era un friki de los Spectrum, mi madre me dice, joder, yo me acuerdo cuando tú me decías, hay una cosa que se llama Internet que va a cambiar el mundo, mamá, y esto era en el año 80 y tantos. Ahora yo veo que la inteligencia artificial va a ser lo mismo que supuso Internet hace 40 años. Algo que viene, que todo el mundo oye hablar, que nadie conoce de verdad. Yo cuando cumplí 30 años con mis amigos de la universidad me regalaron un libro de Internet porque yo era un friki y mis amigos que trabajaban en Renault y en Arthur Andersen y en Internet, ¿eso qué es? Y eso era el año 84. Bueno. El modelo europeo dice la inteligencia artificial lo va a cambiar todo, está lleno de oportunidades, pero hay muchos riesgos. Todos hemos visto detener a Trump en un deepfake o poner a quien sea a cantar ópera. Entonces el modelo europeo se basa en tenemos que regular, una regulación europea, qué es lo que queremos promover en el mundo, tenemos que regular para evitar los riesgos, pero no queremos regular de la manera que esto suponga un freno al desarrollo de inteligencia artificial, porque se tiene que desarrollar, y si no la desarrollamos en Europa es igual, los chinos, los rusos, los americanos, los indios la van a desarrollar sin nosotros. Entonces, esto no se trata de imponer nada, se trata de convencer a la gente. Bueno, nosotros tenemos este modelo, hay 8 modelos más en el mundo y cada país va a elegir el que le parezca. Entonces, en Europa acaba de salir una ley de inteligencia artificial y una de las cosas que estamos haciendo en esa Global Gateway es una alianza digital entre América Latina y el Caribe y Europa para hablar de estas cosas y hablar políticamente y como reguladores, decir, bueno, este es nuestro modelo, hay otros, y pues países como Chile miran muy bien el modelo europeo, países como Bolivia miran mejor el modelo chino y cada uno es como es y tiene las afinidades políticas que tiene. Europa no va a imponer nada, lo que sí vamos es a cooperar con todo el que quiera cooperar. Entonces, este año, dentro de 15 días, me parece, Pía, un mes, vamos a tener aquí, van a tener ustedes la reunión ministerial del ILAC, y ahí vamos a venir con la Alianza Digital a tener una reunión con los ministros, a hablar especialmente de ciberseguridad y de inteligencia artificial. Dentro de la Alianza Digital de los 33 países de la CELAC, bueno, no todos los países están en la Alianza Digital. Hay 22 que han decidido entrar y cooperar que quieren hablar con nosotros, hay otros que de momento no me interesa. Pero con los que sí hablamos se han establecido por grupos y Chile lidera el grupo de ciberseguridad. Chile va a empezar un contrato, no puedo decirte, voy a destrozar la noticia. Cuando vengamos aquí vamos a firmar un contrato con Chile donde la Unión Europea pone fondos a Chile para que Chile haga cooperación con otros países sobre ciberseguridad, sobre cómo ha estructurado Chile la ciberseguridad, su regulación, su legislación, y enseñarles a la República Dominicana, a Jamaica, a quien sea. Esto es lo que hacemos en Chile, crear una ley modelo. Entonces, Chile está en el liderazgo de eso, está en el liderazgo junto con Uruguay y Brasil en inteligencia artificial. La semana que viene van a ir funcionarios de los 3 países, Chile, Uruguay y Brasil, a España y a Estonia o Eslovenia, uno de los dos, Eslovenia, ¿no? Van a ir en un viaje para ver cómo estamos ahí haciendo los supercomputadores, por ejemplo, con el supercomputador de Barcelona. Y tenemos que ser capaces de desarrollar inteligencia artificial en América Latina también. No todos se puede hacer en China y en Estados Unidos. Eso es la transición justa. Si la transición la hacen 4, que son los que tienen las capacidades, incluye capacidades físicas de cómo poner infraestructura dura a un supercomputador y cómo conectarlo a una red. Si solo lo hacen 2 o 3 países en el mundo, volvemos a crear la brecha. Antes era la brecha de dinero, ahora es de digital. Entonces, la Unión Europea está empeñada en que eso no sea así si queremos llegar a los SDGs. En Europa vamos a tener nuestra cierta capacidad, pero hay que hacerlo en América Latina. Y hay que hacerlo que no sea solo en inglés. ¿Por qué no vamos a hacerlo en español o en lenguas indígenas? Eso es lo que trata la Alianza Digital. Es decir, ¿y cómo nos ponemos de acuerdo nosotros, 25 más los españoles, que somos los únicos que hablamos español, pero esos son 500 millones en el mundo, en que esto se pueda hacer en español? Que hay que poner desde el dinero público para poder hacer esto y para que haya científicos, como los que están aquí, que me impresionan, que puedan desarrollar lenguajes en español, en lenguas indígenas, en portugués, en italiano, que es casi igual. Entonces, yo cuando voy a Italia me doy cuenta de que no es nada igual. En Europa tenemos varias experiencias. Está el HPCs, High Performance Computing Network, que es una red de superordenadores, donde uno es el de Barcelona, pero hay otros. Está la experiencia de LUMI, que es un ejemplo de cooperación regional y que se podría replicar aquí, que permitió a 10 países más pequeños de la Unión Europea participar en ese HPC, donde estaba España, Alemania. Entonces dio acceso a capacidades de High Performance Computing a países como Bélgica, Finlandia, que están avanzando, pero la República Checa, Dinamarca, Estonia, Islandia, Noruega, estoy leyendo, Polonia, Suecia, Suiza, que son países más pequeños que a lo mejor no tenían la capacidad, pero con esta experiencia LUME. ¿A Suiza no? Pía. Bueno, luego discuten entre expertos. Suiza, como siempre, puede que esté, no esté, está en la Unión Europea, pero no, es el agujero del donut.
Si quieres...
Yo creo que Suiza será neutral, me imagino. Bueno, eso es un ejemplo de cosas que podemos hacer aquí. Vamos a hacer esa visita de estudio. Vamos a tener el segundo diálogo político entre ministros. Tuvimos el primero, me parece que en Cartagena el año pasado, de la Alianza Digital. Ahora vamos a tener el segundo aquí en Santiago el mes que viene, cuando vengan todos los ministros para ILAC. Vamos a aprovechar a tenerlo. Y bueno, de cara al futuro, nosotros lo que vemos sobre todo es cómo vamos a cooperar en ese high computing, cómo vamos a intentar impulsar nuestro modelo europeo y quién nos lo va a comprar, y eso tiene algún éxito o no, nos vamos todos con Estados Unidos y que Google nos asista. Eso es lo que hacemos. Además tenemos un banco, entonces cuando haya que poner dinero, en Chile tenemos muy poquito porque sois ricos, pero en países pobres tienen más. Okay. Pero para eso tengo a mis amigos de la CAF y del Banco Mundial y del BID para convencerle. Y digo, mira, yo pongo 1 millón y tú pones 1.300 y lo vamos a medias. Entonces ahí estamos. Muchas gracias.
Gracias, Francisco. Ahora le daría la palabra, I will turn into English. I will give the word to Fabricio so he can explain us something that has been done already and that works as a collaborative project for HPC.
Ok, gracias Almas. Buenos días a todos. Bon dia. Good morning. I mean, Latin America and Caribbean is certainly not restricted to the variant of the Spanish language. There is the variant of the Portuguese and the variant of the English spoken in Jamaica. In fact, I've seen that Jamaica is going to be the host of the next Carla conference, which is certainly welcome. So maybe a couple of words why I'm here. My history with Latin America and Caribbean goes all the way back, very much in the context of, so here we are seeing the people who provide money. I'm the guy who spend the money, okay? So spend, yeah, I think I am. So, so when I was responsible for designing the supercomputing system at the European Center for Particle Physics, many years ago, we designed a supercomputer with the support of the European Commission, and that was also a collaboration with Brazil. I remember I was in Brazil in the mid-90s, and we collaborated at the time with the Universidad Federal de Janeiro, so my story goes a long way back. Then, a few years later, well, I was pleased to hear the winner of the Matteo Valero Prize. He mentioned a number of activities which in reality stem out of two projects that I incubated when I was at CERN. One was Hila, one was Gisela, and they were really bringing the technology we developed at CERN and with the rest of the European Union partners to Brazil and to Latin America. Then I moved to industry, I moved to Microsoft Research. I was the director for Latin America and Caribbean for Microsoft Research engagement, and I still have a very, very fond memories of Santiago because I helped Pablo Valenzuela and his wonderful wife, Benedita Mendez, to build the computing system for La Fundación para la Vida, so I was here in Santiago a few times. So just to say that my history with Latin America goes a long way back. Now, more recently, I moved now to the Barcelona Supercomputer Center. I'm involved in the European Union HPC program that Paco was mentioning. And in that context, we believe that we should do more between Europe and Latin America. So we had a very, very small kind of pilot project, a few $100,000 with the idea of increasing the collaboration between the HPC community in Latin America and the HPC community in Europe. We had a few partners in Europe, Vermore, from Jülich was part of the collaboration, but we also had Cineca, we had INRIA, and I'm pleased to see that there is an INRIA lab here in Santiago de Chile, which is certainly very good, and there are similar INRIA outpost in the rest of Latin America, which is also very good. So we did that. The project was called RIS2. RIS, I think, stands for Red Interamericana de Supercomputación. And basically what we did, with the little money we had, is to basically do a mapping exercise of the HPC situation in the Latin America countries. So I'm pleased to see that CAF, I think, is doing something similar. That is definitely mostly welcome. Then we deliver the result to Scala. Hopefully Scala will continue to maintain that information up to date. And then we organize what is normally called capacity building. So we support the organization of school in Latin America. We funded students from Latin America and Caribbean to come to a school that I've been running for almost 5 years at the Barcelona Supercomputer Center. It's an ACM branded school, so it's the ACM School for High Performance Computing and AI, which we ran also 1 month ago. Again, very successful, again with participation from Latin American, Caribbean students. Some of them, they just came and shook hands with me during this conference. So that is what we have done. But more important is what we could do. And so I'm very pleased to be here with entities who can help us to do much more. And why now? Because I believe that now, as said by many people, we're at an inflection point. So high-performance computing traditionally has been, for us, the scientists, to do fundamental research, very exciting. And I mean, let's say the rest of the people, the normal people, didn't really have much to do with that. So, you were mentioning internet. So internet was a kind of Copernican revolution because you basically move computer down in the life of everyone. So after the internet and very much, the web, I mean, Tim Berners-Lee was working in the same group as me, so I had the chance to see the web, being invented. So that has really changed the way in which people, represent computers. So now everyone carries one supercomputer in their pocket called a mobile phone, and therefore, computer at a certain time in our recent history have really changed the way society works. And now we are at the beginning of another revolution, the revolution of the AI. I mean, because of the AI, any activity of humankind, in economy, in everything, commerce, social, is going to change in a dramatic way. Most of the resulting consequences, hopefully, are going to be positive, but we need to be careful. So I definitely welcome the emphasis of the European Commission try to control things that don't really go in the wrong direction. I think there was a meeting specifically in Uruguay yesterday and continue today, where the ethic and the regulation are being discussed. So I'm very pleased that Latin America are definitely taking a leading position there, and for as much we're concerned, it's changing really the landscape in high-performance computing. High-performance computing, as we have seen, in the many talks we heard, is an enabler of AI. So it's not any longer for us, the strange scientists that do fundamental research. No, without high-performance computing, you cannot do artificial intelligence, especially the kind of artificial intelligence that is more specifically called generative AI, because it's artificial intelligence that can generate from data new things, new ideas, advice, hopefully not hallucinating as sometimes it does. But so I think the trend is positive. The risks are many and high, and the biggest risk is a complete dependency from the rest of the world, from United States, and the big elephant in the room that people are not seeing, but I see, is China. So US and China are dominating the AI development in a big way. So there's not just leading, no, they are dominating in a big way. If you look at at all the tools that you see around, and that we mentioned here, they're actually, with the exception of the Chinese, that we don't know much what they're doing. Well, actually, we do quite well, but we are not supposed to speak about it. They're all from California, with the exception of Microsoft, which is a little higher up. So basically, they don't even come from the United States. They come from the West Coast of the United States. And there are very, very few. I mean, you can count them on your hands. And they do a fantastic job. What they produce is very, very good. Behind that, there are hundreds of billions of investments. You can call it whatever you like, the data center, the iFactory, etc. This company have been developing, are investment of hundreds of billions, and that gives them a tremendous advantage. Now, what is even more dangerous in my mind is that because the service they give you are so good, and basically, I mean, I receive every week, not to mention anyone from Amazon Web Services, a request for doing my research on their training, training platform, neural network training platforms for free, of course, in exchange of my scientific data. So fast forward not 10 years, fast forward 2, 3 years, there is the risk, or almost the certainty is more than a risk, that most of the scientific data production is going to be host, own, control, well, you choose the variation in the semantic, by very few companies, you know, Amazon, Microsoft, Google, you name it. And that is very dangerous, because I mean, everything is based on data, and who owns the data owns control over the world. And you know, what I mentioned is not just the economy, it's not just the commerce, it's our freedom, it's our independence. So the rest of the world is not just China and United States, there is Europe, which is pretty well advanced, is one of the most powerful commercial market in the world. There is India, you know, the global south. There is India, there is Africa, there is Latin America and the Caribbean. So if we're not careful, if we don't unite our resources, because we all share the same problem. The problem is to be completely dependent by one of the, so you can choose in which way you want to die. You can die speaking Chinese or you can die speaking English. You choose.
Okay.
Okay? Or both. If you are very good or if you are, you know, masochist, you can do both. So that is really what I would like to propose, and I'm pushing, and a very good discussion with the European Commission, with the Director General INPA, with the Director General DG Connect, and I'm now very happy to be here to be able to engage with let's say the funding agency here to try to develop a program where, you know, maybe inspired by the experience of RIS2, we can really bring the European scientists and the Latin American scientists, possibly with the support of industry, both sides of the Atlantic, and try really to develop a program for moving forward and have an alternative to the American-Chinese predominance.
Muchas gracias. Yo agradezco a todos los panelistas que nos han resaltado las problemáticas y y a dónde queremos llegar. A mí me gustaría usar estos 10 minutos que nos quedan para optimizar las preguntas que les quiero hacer, y quiero que me contesten brevemente, si es posible, sobre, tenemos desafíos, pero tenemos también sinergias que hacer. Tenemos sostenibilidad que pensar, no solo en sostenibilidad financiera y técnica, sino también energética, y recomendaciones que hacer. En su visión, y tenemos aquí a la población académica y científica del tema de cómputo de alto desempeño, los hemos invitado a ustedes. Tenemos a los que están más asociados de la iniciativa privada en este sector, pero quizá nos falta el gobierno. Entonces me gustaría que, en resumen, nos pudieran aportar qué elementos concretamente pudiéramos tener para iniciar. No hablé de Scalac, fíjense que yo estoy representando a Scalac y se me olvidó hablar de Scalac. Scalac ya es una iniciativa que tiene muchísimos años trabajándose, como se trabajó Red Clara en el pasado. Entonces ya hay un avance de colaboración desde la perspectiva de los que administran máquinas y de los que usan máquinas, pero no hemos logrado esa sinergia que necesitamos con otros actores relevantes. Entonces es muy importante para nosotros saber, ustedes de la experiencia que han vivido, quizá no en este tema, pero sí en otras comunidades, cómo podemos nosotros avanzar y qué podrían hacer ustedes para facilitar esa sinergia y esa cooperación que se tiene que dar para esta infraestructura colaborativa, que es de impacto a todo lo que mencionaron anteriormente, ¿no? Es de impacto a soluciones de problemas no solo regionales sino mundiales, a soluciones de la brecha digital que tenemos y a soluciones de la participación que cada uno de nosotros tenemos como ciudadanos del mundo, en que este planeta siga subsistiendo para que podamos vivir en él mientras no tengamos otro planeta a donde ir. Entonces les doy la palabra. ¿Quién quisiera comenzar?
Bueno, gracias por la pregunta tan amplia y como es cortito voy a tratar de resumir un par de puntos que yo creo que son relevantes en esto. Uno es que efectivamente es una oportunidad, a pesar de que los desarrollos están, como dice el profesor Fabricio, concentrados en algunos lugares del mundo, la capacidad de poder adoptar y adaptar rápidamente la tecnología puede generar un espacio para desarrollo local. Los datos finalmente que hoy están disponibles son precisamente concentrados porque han sido los primeros lugares y espacios donde se logró tener este rápido mecanismo de captura y almacenamiento y de feedback process de poder tener cada vez más datos. Pero hay un montón de actividades económicas y sociales de nuestra vida que todavía no están, digamos, en bases de datos ni están siendo sensorizadas. Y ese espacio, digamos, en el cual no se van a estar dedicando los recursos porque los datos no están todavía, es un espacio para generar una ventaja comparativa en la región. Ejemplos podemos encontrar potenciales al menos, por ejemplo la Amazonía, y la probabilidad de poder desarrollar como AI-driven bioprospección, por ejemplo, y tener un espacio de desarrollo de bioeconomía a partir de la incorporación de herramientas de inteligencia artificial en esa ventaja natural comparativa, que además nos permite abordar parte del desafío del cambio climático y encontrar una manera sostenible de mantenimiento de la Amazonía. Nosotros como el banco y como creo CAF y todo el resto de las organizaciones multilaterales también podemos dejar espacio para aceitar la relación entre los países para lograr modelos de acuerdos colaborativos, en principio también poder replicar modelos como la Red Clara de compartir infraestructura de alto costo individual pero de muchos beneficios compartidos. Creemos que el modelo también de los observatorios astronómicos del norte de Chile puede ser replicado quizá en algunos lugares donde existan ventajas también comparativas de energía limpia, de bajo costo marginal disponible, donde podamos explorar también, instalar, con el compromiso de los países involucrados principalmente, explorar modelos como ese, y por supuesto desde el lado nuestro van a encontrar el apoyo necesario porque creemos que el habilitante de High Performance Computing es necesario junto con, digamos, el aprovechamiento de estas oportunidades económicas, desarrollar efectivamente el talento en nuestras comunidades a los diferentes niveles y tener unas instituciones y gobernanza que nos permita que esto se haga de una manera en que beneficie a todas las personas de nuestro continente.
Y si puedo añadir un punto ahí a tu pregunta también, Salma, al final, ¿por qué la relación usual de los bancos de desarrollo es con los gobiernos, ¿no? Aparte, claro, de los brazos no soberanos? Ahí tenemos una oportunidad también de traer a la mesa esa institución, ese tipo de institución, para que también eso se haga no a nivel no apenas de regulaciones, sino que a partir de políticas públicas de desarrollo sostenidas en el tiempo. Ese es el caso de Chile, por ejemplo, con el Ministerio de Conocimiento, Ciencia e Innovación acá. De hecho, la ministra Edson tiene, ¿no?, como prioridad el tema de, bueno, hacer con que Chile avance cada vez más en cuanto a un protagonista regional en temas de transformación digital, y el tema de HPCs e inteligencia artificial van de la mano con eso. Sabemos que Chile es un hub digital para la región, pero tiene el potencial de reforzar eso, y también es una de las razones que los estudios de prefactibilidad que estamos financiando desde CAF en alianza con MCDF van alineados también y empiezan por Chile y República Dominicana, y ahí me parece que efectivamente también el poder de bancos de desarrollo en traer a la mesa a todos los distintos stakeholders para hacer con que eso se haga en cuanto a política, que tenga un impacto tanto a la comunidad académica como a la sociedad, incluso con un componente de inclusión muy importante, ¿no? Bueno, Fernando ya había mencionado el tema de la bioeconomía en la Amazonía, pero ahí destacaría también otras zonas, bueno, más, no necesariamente rezagadas, pero aisladas en la región. Me refiero, por ejemplo, a la Antártida y todo lo que es la región de Magallanes, por ejemplo, acá en Chile, ¿no? Y con todos los beneficios que pueden traer el tema del cable submarino antártico que se pretende desarrollar ahí y el potencial de despliegue de otros tipos de infraestructura para la región. Ahí se nota, ¿no? Un poco cómo podemos reunir los building blocks y ir siguiendo ahí, entonces promoviendo lo que es un tipo de política pública que sea mucho más integral, ¿no?
Yeah, well, as I was alluding before, definitely the International Funding Agency has an important role, but clearly, is the case for HPC in Europe. I mean, is a share investment by the European Commission and the participant states, which are wider than just the European Union. So I think, the same model is what I would see happening here, and certainly would be welcome. And I think this time, because of what, as I was saying before, I mean, AI is changing also the way in which politicians, the government, perceive what traditionally was seen high-performance computing, so just for scientists. No, AI, I mean, the President Lula in Brazil, a few weeks ago, announced his AI for the good of everyone that was presented by our Brazilian colleagues. And that is a big investment, is the equivalent of 1 billion per year for 4 years. So that is big. But by the way, it's 4 years. So something that a warning I would like to give to everyone, there is need for major investment immediately to build the infrastructure. But infrastructure needs to be sustainable on the long term. So in a way, the investment bank we heard today, well, they have the possibility, for instance, to complement the specific action at short, medium term of the local governments with maybe very long-term loan, very long-term financement that are going to allow whatever is done now on, let's say, on the enthusiasm of a new technology which is going to revolutionize the world, and it's going to happen. But after the initial enthusiasm, I think everyone is familiar with the 5 phase. So after the initial enthusiasm, there are going to be some disillusionment because, I mean, there is an investment of trillions of dollar, euro, whatever, trillions, not billion, trillions, worldwide. And it's mostly private. So private, they need to see a return. So I'm not entirely sure that in the short, medium term, the AI economy is going to generate trillions of return. So there's going to be a moment of disillusionment that is very healthy because people are going to understand a little bit that, is not it's not really the panacea. And at that point, it's important long-term sustainability. You buy a computer. We just installed the Barcelona supercomputer Mannerstrom 5. It's an investment of 220 million euro, 50% paid by the European Union, 50% paid by the Spanish government. Well, that system, you can buy. I mean, you find, there are plenty of vendors here. They gave us interesting talks. You go to them, you sign a check, and you install the system. Yeah, but you need the people to operate it. So that's why the training, the education, everything I've been trying to do with my previous prototype project, and I really would like to do now with the help of the funding agent, is so important. Because, the investment you do on the computer in 5 years is obsolete, throw it away, you buy a new one. You need the people to use it in a good way. And then you need the long-term sustainability because, behind the computer there is the long-term energy supply and, the whole ecosystem they will need to maintain over and over. And so that's why I think there is a good balancing act between the investment banks, the European Union, the other very, let's say, international entities, and the local government. Local government, we know by experience, so the politicians, they need to be re-elected, so they privilege the medium and short term, but we need the long-term sustainability. So I could see really an ideal world in which there is synergy from all the different parties, us the scientists, the international funding entities, and the local government.
Gracias. Sí. Y luego hay una segunda parte de todo eso. Por una parte, para desarrollarlo necesitas la inversión privada, la iniciativa privada, necesitas científicos que lleven las cosas más allá, necesitas todo eso. necesitas acceso de la gente, necesitas que esto no sea solo para unos privilegiados, que yo pueda hacer el briefing a mi jefe con ChatGPT, pero el señor que vive encima no lo puede hacer porque no puede pagar ChatGPT porque te cobra 6 euros al mes. Eso es toda una cosa, pero lo que tú planteabas cuando decías nos faltan los gobiernos, yo vengo no de un gobierno, pero de un gobierno de gobiernos, mis jefes son los políticos que les tienen que elegir y votarles y lo único que les importa es quién va a ganar las elecciones el mes que viene y sus decisiones las toman con esa lógica, porque si yo no gano las elecciones nada de lo que yo haga sirve. Entonces, y eso es parte del paisaje y hay que vivir con eso. Ellos no cuentan el dinero en inversión o en dinero, yo cuando lo descubrí lo cuentan en votos. Esto da votos, esto no. Vale. Pero la dimensión de lo que tú has mencionado es tan grande que ningún gobierno lo puede resolver, ni el gobierno de Estados Unidos solo. Cuando tú hablas de no solo los problemas morales de la inteligencia artificial, no solo si la inteligencia artificial o la supercomputación la van a controlar los buenos o los malos. Se va a usar para el bien común o se va a usar para el crimen como se está usando. Se va a usar para el deepfake y la desinformación y prostituir elecciones en sitios, o se va a usar para espiar, o se va a usar para la ciencia y para... Eso es una parte. Están los problemas morales, que lo típico, ¿quién le va a decir al coche que se maneja solo de Tesla autoconducido? ¿Quién toma la decisión moral en un accidente inevitable? Si atropellas a la vieja porque le queda poco, o atropellas al niño porque se muere menos o porque es más rico. ¿Y quién programa ese coche para que tome la decisión? Todo eso, hay 1000 modelos en el mundo. Están los cristianos que piensan de una forma, los musulmanes de otra, los budistas de otra, los ricos de otra, los pobres de otra, los científicos de una. Pero luego están todos los problemas medioambientales, sí, supercomputadores y la energía y el cambio climático. Y ahora vamos a llenar la Patagonia de centros de hidrógeno verde para alimentar supercomputadoras. Hablabais de la Antártica. La Antártica, que es el paraíso que nos queda en la Tierra, está llena de calderas de gas. Nosotros tenemos un programa para ver cómo sustituimos eso por hidrógeno o por energías renovables. Entonces son de tal dimensión que es otra vez la humanidad está al borde de un precipicio, no en el sentido negativo de que nos vamos a caer, al borde de un sitio donde saltas para un lado, saltas para otro. Yo creo que la humanidad ha tenido históricamente la capacidad de llegar al precipicio y saltar para el lado bueno. Lo hicimos con la bomba atómica, lo hicimos con el Holocausto, fuimos llegando hasta un sitio donde dijimos, para, y aquí hay que parar. Y para nosotros los europeos, la inteligencia artificial, sobre todo, que es el gran desconocido, hay que ponerle en algún sitio, hay que conducirla para asegurarse de que la inteligencia artificial, como pasó con Internet, Internet era el sitio de la libertad, donde todos podemos ser libres, donde nadie nos va a controlar, ningún gobierno nos puede controlar, bueno, hasta que nos pasamos y empezamos a ver el dark web y el no sé qué, de, bueno, algo así hay que controlar porque el ser humano no... Entonces yo creo que estamos en eso y para mí hay 3 claves ahí para ver lo siguiente. Es cooperación y diálogo la primera, la segunda es cooperación y diálogo y la tercera también. Ni Naciones Unidas, ni el gobierno de Estados Unidos. Y eso es lo que intentamos hacer la Alianza Digital, en pequeñito con nuestro modelo latinoamericano europeo. Hay otros modelos, esta conversación que ahora empezamos entre nosotros los latinos en español, hay que hacerla y se hace a nivel mundial, hay que hacerla en el marco de Naciones Unidas y más allá, y hay que convencer, es como el cambio climático, de nada sirve que nosotros aquí en Chile seamos los más verdes del mundo y en Europa también, si en India y en China no están convencidos de eso y nos dicen, no, es que ustedes contaminaron cuando se tenían que desarrollar, ahora me toca a mí desarrollarme y me toca a mí contaminar, y no me venga ahora el país rico a contarme que tengo que proteger el bosque, porque... Entonces yo no arreglo nada siendo yo verde si no soy capaz de convencer a los otros que tienen sus buenas razones, y con lo digital pasa igual. De nada sirve que yo ponga el Data Protection Regulation en Europa si en Suiza, que ya no es la Unión Europea, no lo tienen, o si en Inglaterra no lo tienen, o si en India o en Afganistán no lo tienen. Y si cualquiera se puede ir a montar su servidor en Afganistán, bueno, eso es difícil, pero en Rusia sí, y pasarse todo lo que acordamos entre 100 gobiernos por donde pueda, porque hay un gobierno que dice que no y que a mí no me van a regular. Entonces, yo creo que pasa por ese tipo de diálogos políticos, donde no es un diálogo entre políticos, donde tienen que estar los científicos, donde tienen que estar los usuarios, donde tienen que estar los financiadores y donde tienen que estar los expertos que manejan esto. Y esa conversación es muy difícil, pero históricamente la humanidad le ha dado.
Thanks a lot. Let me shift to English for probably this last intervention. So just to highlight, I think, to the point that Salma made, the first key ingredient that we see is the commitment. For instance, the bank has created a new vice presidency on digital. I imagine that this footprint from the top level also will help and will enable to have more resources, more specialists, more people trained on the new and disruptive technologies. So we're trying also to support governments in that same regard. And we have seen the new leaders in this recent year putting in their programs during the transition and during the electoral campaign, digital also at the center. I think the Mexican president just had a quote last Monday on the importance of digital when she took over as the first woman president in Mexico, and congratulations for that. So secondly, we see as well there is a need to have holistic programs, and we mentioned initially the need to have investment, and I think Fabrizio mentioned the importance of having skilled people. So you need to have programs that will tackle not only the infrastructure, but also will help training people in advanced skills, but also not leave people behind. And I think, echoing what Paco mentioned, we need to close the different gaps. We have the digital gap, but we have also the gender gap, and some colleagues mentioned on STEM, on IT skills, make sure that we bring all the population. Also the aging gap in digital is also one of the ones that sometimes stay silent. And finally, just to mention the need to have, as you all mentioned, the cooperation, the dialogue, and the commitment to bring probably some standards. We've seen very advanced standards and safeguards that need to be part of the different interventions. Cybersecurity, data protection, there are different references across the world, and I think we need to be neutral brokers in the development organization, and we need to bring as honest and trusted partners, as colleagues mentioned, these standards and offer these as technical assistance, as cooperation to the countries to make sure we can reach a more development and inclusive, resilient, green development, and that brings as well to the development sector in the ICT and digital arena. Thank you.
Muchas gracias. Se nos acaba el tiempo. Yo solo quiero decirles que estamos muy agradecidos de que hayan participado aquí y que veamos que sí hay un interés por la región, eso es muy importante, y que ese interés se traduce en cooperación, como dijo, cooperación y diálogo, y acciones que tenemos que realizar en una ventana corta que tenemos, por lo que vamos a seguir buscándolos para poder concretar lo que nosotros hemos construido a lo largo de varios años y que queremos que sea no solo para nosotros, sino para el mundo. Muchas gracias. Les voy a dar sus diplomas.
Aquí tenemos diplomas.
Ay, para la foto, perdón.
Invitamos a tomar ahora
un Okay, good morning. We're ready to start our next session, where we will have first a special talk by Carla Jaime Barrios and Philippe Navaux. I guess neither of them needs any introduction. So let's just leave you with my colleague and my brother, Carla Jaime. Take it away.
Okay, thank you very much. Okay. Okay, so now the idea is I need to present what is a Scalac, some numbers that do for the activity that we made. For this presentation that we went with Professor Philippe Navaux and me, we also, I guess, presented Nicolas Kolovic, mainly to prepare a discussion about some of the data that we have. So, a little about us. So, it's important to say that in Latin America, there are interesting ecosystems with a good research background. So, if we see the select numbers and some Ibero-American data, we have important universities in the region. But the most important for us is the partnership that we develop with different countries. It's interesting to see how, for example, we made a strong collaboration with Europe. You can see in the graphic. It's very, very important. And the most important for this data is the countries, because we say, okay, we are in an Ibero-American region, but there are more collaboration in computer science with France than with Spain, for example. And it's important also to see the important number for the Germany collaboration. That is very good for this side. The other number from USA and Canada is only the 27%. That is important to say that is the official collaboration, and really in computer science in both ways. There are also the collaboration with China, South Korea, Russia, India, and the others. So that presents an important background about. Another thing that is important, we talk a lot about Scalac. So Scalac is an alliance that starts after the first grid projects and advanced computing projects. Mainly as a consequence of a project that at the time was led by Luis Núñez in the Gisela project. And Scalac officially was created with the communities performed by Red Clara in this time. Another thing that is important that also we joined the supercomputing projects, mainly the RISC project led by Barcelona Supercomputing Center. And we have three main European actors in this collaboration. No? The first one, of course, the Barcelona Supercomputing Center. The other one is the CMAT, ZCMAT in Spain. I think that is not in the graphic. And the other one is the INRIA CNRS actors. No? Of course, there are other ones like the CERN, the INFNs, the Chineca, and others. Other thing that is important is for us, we have another collaboration, not only the collaboration between the countries. We hope that in a short term, Panama, for example, start a new time the collaboration with us, and soon Bolivia, Jamaica, República Dominicana, and Peru. For the other way, we have global collaboration, of course, the Euro-HPC, Latin and Caribbean collaboration, via the different European Union frameworks, like is the case of the RISC project, for example. But there are, some years ago, we started an important collaboration with the continent that we named America's HPC collaboration, mainly with the interaction of Scalac, the Department of Energy of the United States, and the Alliance Computing for Advanced Computing for Canada. No? So here, for example, we have the presence of Silvio Risi, one of the laboratories that is part of this collaboration, the American HPC collaboration. But more than share the HPC capabilities, the most important for us is to share knowledge and to join people. That is the very important for us. So in August, we made the General Assembly. So now this is the new current council, the new advisory council of SCALAC. So the president is Professor Philippe Navaux. The vice president is Salma Khalifi, that you know in the last panel. The secretary is not here. That is Álvaro de la Osa Oseguedo. Treasury is Carla Stoff, that is here. We have two vocals, Professor Harold Castro from the Universidad de los Andes in Colombia, and Nicolás Folovich that is here from Argentina. And the fiscal is Luis Eliezer Cadenas from Red Clara. Yeah. Yeah, of course. It's different the advisory council with the board. The board is the people that makes mainly the operative work, but also to lead the different activities. No? So, I myself, like general chair, also Esteban Meneses is the vice chair. Ines Guerrero, that is the leader of the strategic infrastructure and service in SCALAC. Lister Robles, like the communication chair. Esteban Moscos, I hope that now is good writing in the slide. No? Ah. And from Argentina, the Training, Outreach, and Education Chair. Isidoro Gilder from Navaux Investap. And we had an important liaison with Red Clara, that by Carlos Gonzalez, that is not here in this room. But there are other people that is part of the board that mainly they interact with the different projects and support the different activities that we have. No? That is the case of Sergio Nechmanov. No, he's not good writing. No, not yet. First time. Yeah. Okay. Robinson Riva from Venezuela. Antonio Tadeu Gómez from the LNCC Sinapad Brazil. Moisés Torres from Red Mexicana en Supercómputo and CUDI. And Claudio Chacón from CEDIA Ecuador. So, about the activities. So, this one, like the Carla conference, I think that after this edition for the next year, we can say that the Latin American and Caribbean High Performance Computing Conference, first time in the Caribbean. The American HPC Collaboration Alliance, I said you before, we developed in Supercomputing Conference a bit of other activity, very important, when we meet the people from the Canada, USA, and other actors. And of course, the different activities that we made with Europe. And I think that it's important that after with Nicolás, we have a HPC LAC observatory. After I tell more about this. And we have some interesting challenges now faced to the artificial intelligence and quantum computing. So of course, we try always to work about the autonomy and non-dependency technology. It's very, very important for us. Is to develop the actual centers. Of course, for us, the artificial intelligence is an user case. It's parallel massive processing mainly, with all the things around. But also, we discuss a lot about the sustainability and responsible social impact of these centers in the region. The other is about the transdisciplinary, interdisciplinary approach, mainly with an emphasis in information and outreach. So the idea is to develop all the HPC advanced computing ecosystem. Is to say from the users, engineers, decision takers, researchers. For example, in this edition is the first time that we develop an important school with all the responsibility of the administration and management of the HPC infrastructures in the continent, led here by Nicolás and Antonio. Thank you very much for this. And the idea, of course, is to propose and improve the good practice of the different actors to develop this technology. So we have a strong collaboration with different enterprise, not only the big actors, the big ones actors, like the sponsor of this conference, but also with people that wants to create enterprises, that wants to interact, for example, for the energy or oil and gas enterprises to develop different activities, and of course to make the global collaboration. We had two important activities that we made this year. The first one was an interesting panel that we developed in Madrid. There are 2 months ago, when we discuss for some responsibilities to observe how we can improve this collaboration, observing not the actual collaboration we made, but the research lines that we can develop with Europe. So in this photo, there are Jesus Carretero from the Universidad Carlos III and part of the steering committee of EuroHPC Untertaken. There are Pascal Borin from Universidad de Luxemburgo, University of Luxembourg, and the leader of the EuroHPC master. So we have an idea maybe for the next year to present a proposal to extend following an Erasmus Mundus programming master with the experience that we observed, for example, in the different masters that also were led by Luis Núñez in ESA Particulars, to develop an EuroHPC master, but with an extension in Latin America. And the other one, the other photo, sorry, is a photo of the last week. We participated with Philippe Navaux with the presentation of the second Artificial Intelligence Index, where Scalac support the action with some data. Some of the data were presented for the people of the Mundial Bank there are a few minutes ago. So now about this Scalac HPC Lab Observatory. So this is a heritage that we reside of the RIX2 project. So the idea is to observe what happened with the different elements of the HPC ecosystem, not only the machines, so the people, the use, whatever. So we made a first version in August, public, and the version 2, after the revision of the revision that is there, will be available the next week via the site of the Scalac. It's important to say that this report is made by Nicolás Bolovic, Luis Alejandro Torres Niño, and me, and the revision is made by the president of Scalac, Professor Harold Castro and Professor Esteban Meneses. So about this, so now, pass the Nicolás to discuss a little about this because we find some interesting things. Please, Nicolás.
We just asked for the system administrators to give us few numbers, very few numbers. These are comments from the Slurm workload manager, and we asked them to run 2 commands and get 3 columns. That is the results. We are committed to show what we are in terms of those parameters. You may see that there are very bad numbers. You may see that very good numbers, and that is what we need. And we learned a lot from this very simple exercise. For example, that there are some centers that don't have the capability of running that commands because they don't have the database installed, and that is a very good lesson to learn. You really need very few steps to get this command running, and they are important. And we want this just to be a sneak peek of what comes. We need these indicators to improve, and it's easy to improve them. We believe that. We believe we can be on par with 70% of utilization and with very low downtime, as low as 5%, and we can have more than 100 users per center. We can do it, but we have to have the numbers, and we have to believe in those numbers, because without measuring, we cannot make policies, and we become less credible, above all for multilateral credit banks, for example. So our idea is to continue doing this. This was just a pilot. For us, it was very interesting. The results, what we get and what we didn't get. That is the important. We didn't get some results. I encourage people to show their numbers, because this is the way to improve. We are scientifics. We believe in measurements. We believe in improving those measures. So we just reach us and ask for the 2 commands. I've just sent to all the administrators in the DevOps schools they already have the comments, and we encourage you to make at least the comments to be possible to run. And this is a very, very important first steps. This is like primary health care. How much you weigh, how tall are you, which is your age, are you eating 3 meals a day? Basic, but needed, fundamental for the health of the system. So that is the idea. We don't want to measure the money that we have, because we have little money. But the money that we have, how we use it. This is Latin America and Caribbean. We know it. So it's just that. The numbers are there. And we hope that in 2025 to have a longer list and an upgraded list, in the sense that, hey, we now can run S-report. Hey, we now achieve more amount of users because we just make publicity of our center, or gave accounts to everybody in a massive way, and we want the equipment to be used. It's just our aim. Thank you.
Thank you, Nicolas. So there are two things to say about. Yeah. I see that there are no happy people in the in the room, but that is the idea, of course. So also we try also to to send a message, really, to have data, to develop the things, of course. It's not a concurrency, really. However, it's important to say that we have interesting center here with a lot of users, like the case here in Chile, so more than 300 people. It's very, 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 very interesting. Also, the percentage of users that we can follow in the case of the Santos Dumont, that is very, very high. It's not a huge machine. It's a very good use of the machine, so it's very, very nice. And of course, one of the things that for us is important is the problems that we have in connectivity for the different centers. So it's a task that we have with Reclara to guarantee how we can connect the different centers. So it's a task that we have now, because with this we can improve the use of this infrastructure. So this is very important. So just to finish, please, there are a video if you can. So just to acknowledgement to the team of Reclara that creates the new image of Scalac. So thank you very much, Luis Eliezer and your team. So and we're happy that you write us, that you follow us for the X account mainly, but also to visit our website. So thank you very much.
Okay, so before we move on to the presentation of next Carla, we will give away the awards for the best poster and best paper. And okay, I'm going to present the best poster. Okay. First off, for the best poster award, it goes to the poster with the title Non-Invasive Characterization of User Behavior in High Performance Computing System, the case of the Santos Dumont supercomputer, by Juan Fabián and Antonio Tadeo Gomez. So
now we are going to announce the best paper. Is a study of performance portability in plasma physics simulations. A study of performance portability in plasma physics simulations. So there is a problem here in the, we have to fix. So I would like to ask José Ruzica for
Liz. Algunos certificados. Okay, okay, so now we have some certificate for the general chairs and chairs. So please an applause for Ginés Guerrero, for being the general chair of this. Jaime, please, also for you. And the co-chair of this conference, please.
No lo merezco.
No, claro que te lo mereces. For the National Laboratory HPC team, so I don't know if you or all the guys, if there, or one representative, please.
También. Vengan.
Vengan.
¿Dónde está Pedro? Los que están trabajando no están acá.
Yes.
Sí, pues los que
Yeah.
están trabajando acá, pues.
Also for the team of the Centro de Modelado Matemático. I don't know if there are the guys there.
Sí,
Okay.
yo lo puedo recibir.
And of course for the CATS team. So Liz and Angie, please come here. Okay, so now the picture, I don't know if there. Sí, pero toca. Llegó Philippe.
Sí. Okay, now we want to call Kevin Brown on stage to give the presentation for Carla next year.
As you can see, I'm pretty sure I'm the slowest Jamaican in existence. Hi everyone, my name is Kevin Brown and I will be one of the general chairs for Carla next year in Kingston, Jamaica. So the other general chair is Esteban Meneses, who we all know and love. And since this is my first time on the Carla committee in this capacity, I'll introduce myself very briefly. So I was born and grew up in Kingston where I did undergrad. Then I worked for 4 years in industry as a system administrator. Then I went to Japan for 6.5 years to do my master's and PhD at the Tokyo Institute of Technology under Satoshi Matsuoka. During that time, I spent some time in Livermore doing summer internships, a month in Barcelona doing an exchange visit. And then I decided to be a bartender after I graduated. And I failed, so I became a postdoc instead. During that year, between graduation and postdocing, I lived in Mexico City for 6 months. I went to Medellin for a month and then continued to travel the world. Before going to Argonne National Lab, where I've been now for 5 years working on supercomputer network performance analysis. Now, as Carlos Jaime said, this is the first time Carla is going to be in Jamaica and in the Caribbean. So we're looking at it not just Carla Jamaica, but Carla for the Caribbean. And we'll be connecting with other Caribbean islands. There are 31 territories, speaking English, Spanish, a bit of Dutch, French, and so on. And in total, we have over 43 million through the Caribbean islands. Jamaica is the 3rd largest island by landmass, but the 5th largest by population. All right. So, next. Oh, yeah, there we go. So, we are happy and looking forward to welcome you all in Jamaica so that we can expand the reach of the Carla community and so that we can share the Jamaican culture with everyone. Jamaica has a population of just over 2.7 million. The size is 11,000 kilometers squared, and their language is English officially, and not American English, but British English. But locally we'll speak Patois, so if you're listening to Sean Paul, Bob Marley or Junior Gong, you'll hear them say Wagwan, Medea, Yemen, everything good. That's that's the Jamaican part. And we'll have some training sessions to prepare you before you get there. Yes. So when you think of Jamaica, I imagine you all think of some of our icons. Cool Runnings was a movie about the Jamaican bobsled team. We participate in the Winter Olympics and we don't have snow in Jamaica ever. So it's a very interesting movie to watch our story. Usain Bolt, the fastest man in the world, and we're happy, we can associate supercomputing with Jamaica. Fastest supercomputers, fastest man. It's a match made in heaven. And the legendary Bob Marley. I don't know what else there is to say, but Bob. So these are some pictures of Jamaica you won't find on the internet. These are pictures I took while I was still living there and traveling with my friends. Our Blue Mountain Peak, we do have Blue Mountain coffee. I'm not going to start a coffee competition in Latin America. We do have a lot of nice forested areas, very small. You could do cliff diving, go for some fried fish on the beach. A high school leadership program I organized for high school students across Kingston, and just go coast down the river in between the coffee breaks, or for the coffee breaks, not in between the coffee breaks. And folks have been asking, so I do provide the foods. You will see a lot of similarities between the coastal regions of Latin American countries. We do have soup, which is like sancocho in Colombia. We do have something which is like the empanadas in South America. We call them patties. They're much bigger, crispier on the outside. And we do have the rice and beans, like my Costa Rican friends will tell me, rice and beans. Now, getting there is fairly convenient in many ways. The conference is going to be in Kingston, which is on the south coast of Jamaica. And the airport in Kingston has these connections. It's an hour and a half from Santo Domingo, 2 hours from Panama, and 10 hours from London for our European colleagues. These are just direct flights, so of course, if you have connections, you can go through any of these hubs. And Montego Bay is on the north coast. That's where most of our nicest beaches are. So if you've ever taken a cruise to Jamaica, you'll probably go to Montego Bay, Ocho Rios, Negril, or one of these places. And there are different connections. Here, Miami is an hour of 40 minutes, Lima 4 hours and 45, and Frankfurt, pretty close to our friend Bernd, just 10 hours and 40 minutes. This is a picture from Kingston, a central area we call New Kingston, which is one of the business districts. And when we think of having the conference in Jamaica, I'm sure everyone wants to go. And everyone has an impression of what Jamaica is, the music, the culture, the food, the vibes, and so on. And we all have a vision of what Carla could be throughout the Caribbean. And I'm really excited by this, and I want to share all of your ideas. Want you to share all of your ideas with me and Esteban so that we can make it into what you want it to be, so that we can grow Carla and also include the Caribbean region. And this is my last slide in terms of what to expect. Jamaica, we have 2 major universities and a few smaller ones, but neither of them have a supercomputing center, and we don't have strong HPC research for graduate programs. So this would be a unique opportunity for us, the Carla community, to continue growing HPC in the region and building on that. So I'm looking forward to all of your collaborations, from the researchers to the industry partners to the students, to spread this reach. So we'll be, for Carla 2025, growing and exploring new cultures. We'll be building new collaborations. You're expanding to a new market, and we see a lot of new opportunities. But primarily, we will ensure that it's the same Carla spirit that we have every year that keeps people coming back to Carla. So looking forward to see you all in Jamaica next year. And just to, like whet your appetite of what to expect, to see the joy we feel in welcoming you, I'm going to invite them to play a video. I think we all know this song, right?
Because
thank you again to Chile and the amazing team for this year, and we welcome you all to Carla 2025 next year.
Okay, so a couple of announcements before we wrap this up. Okay, yeah, so we need to take the group's picture after this, so just don't run away. And we have a short message by Esteban Hernandez.
Okay, thank you. My name is Esteban, like Esteban and Esteban. Okay. I am probably the more looking person in Colombia because was the first doctoral student of Carlos Jaime's. For me, it's a very special moment, understanding that Carlos can probably move to the next step. I really hope that probably return very close to Colombia, but I believe that is the moment for recognize all the work. And we are here present, all the students, all the collaborators, all the rest of the community that working very, very close. Then Carlos, please come on. We have a couple of symbols. I need the Carlos can read that and express all our thinking for you.
Okay, thank you very much.
Please read aloud. No, that is Chinese. It's Mandarin. It's like it's very similar when Carlos talking with me the first time. I don't understand anything. Yeah, especially when call me by phone. The second is it's a general question. What is probably the second more important activity for Carlos, additional to be present in different conference? What? General question. What is? Fly. Okay. Then this is a scale model or Air France. Yeah. I understand that you love France. Then, Professor. And this is a special gift of Jen, because this chocolate is very special. But the most important thing is this book. This book expresses all the ideas, sentiments, etc., that your people, your collaborators, the close person that working with you, like and need be expressed probably for the next couple of years. Thank you, Professor Carlos Jaime.
And for a final speech, we will call Jaime San Martin.
Okay, the end is here. So we will see a short video of the conference as a gift for everybody. It's like 10 minutes video.
A true honor to be here in the inauguration of this conference and to be a part of this amazing group of people that is trying to push forward the capacities on HPC, not just for Chile, but for Latin America.
Conferencias como esta, como Carla, que ponen en relieve la importancia de la infraestructura, del cómputo, la importancia de la colaboración a nivel latinoamericano son fundamentales. Si queremos avanzar en el desarrollo y en el bienestar de las personas, si queremos resolver los problemas del cambio climático, enfrentar los desafíos de la salud, fortalecer nuestras democracias, necesitamos tener capacidades en materia tecnológica. Y esta conferencia se trata precisamente de eso. Así que felicitaciones a los organizadores, al HPC, a Ginés y todo su equipo, a la Universidad de Chile y por supuesto agradecimientos a Carla y a todos los involucrados en este seminario por traerlo a Chile y permitirnos tener durante estos días estas importantísimas discusiones.
Carla 24 está siendo un suceso. Felicitaciones a toda la equipe comandada por Ginés y tal. Claramente podemos ver en las reuniones, en las charlas, en los sponsors que están acá, ¿no? Lo interés que hay en la conferencia. Y las personas están viendo. Y por tanto, tenemos los investigadores, tenemos los estudiantes, pero tenemos también las empresas que vienen acá porque ven que es una conferencia importante en HPC, en computación de alto desempeño. Y por tanto, están interesados en ter aquí su participación, presentar sus nuevas máquinas, sus nuevos sistemas y tal. Y estamos en un momento muy interesante, donde todos los países, ¿no?, especialmente de la América Latina, están olhando para el desarrollo de HPC por causa de la inteligencia artificial. Entonces, Carla está catalizando, no sé si puede decir eso en español, agregar todas las empresas y las personas para el desarrollo en la América Latina de HPC.
How to reproduce, how to replicate. In this case, it has made easy with the networks. If you trust the networks, then to run the whole workflow is not so complicated.
Mi charla fue sobre diseño de chips, de aceleradores para la inteligencia artificial. ¿Y por qué? Porque es el tema más importante que hay hoy en el campo de la arquitectura de computadores. ¿Cómo diseñamos chips que ejecuten las nuevas aplicaciones y las que vendrán de inteligencia artificial con el mínimo coste energético y la máxima velocidad? No, normalmente acudo a los Carlas porque es un punto de encuentro entre la comunidad latinoamericana y es un punto más donde me encuentro con los países que yo quiero mucho, con las personas que quiero mucho, que conozco hace mucho tiempo. Luego vengo realmente a ver a mis amigos y a disfrutar.
El Carla es la conferencia internacional más relevante que se hace en Latinoamérica. Llevamos más de un año trabajando para poder materializar este congreso. Después de 10 años, desde que se hizo en Valparaíso la primera edición, está volviendo a Chile, concretamente a la Facultad de Ciencias Físicas y Matemáticas de la Universidad de Chile, con el apoyo del Centro de Modelamiento Matemático y el Laboratorio Nacional de Supercomputación de Chile. Es importante mencionar que hemos tenido el apoyo de 17 empresas, de las 17 empresas más importantes que podemos encontrar en el panorama de la computación de alto rendimiento, que han decidido que es un evento relevante a nivel internacional y que han de apoyarlo. Es súper importante los lazos de colaboración. A ver, no estamos solos en este mundo. La idea no es solo Chile tiene que reinventar la rueda, tiene que comenzar a armar la supercomputación desde cero, sino que al final hay que armar lazos de colaboración con los distintos países. Este año hemos realizado 5 workshops temáticos, 6 tutoriales avanzados, 5 paneles de discusión y ha habido más de 30 prestigiosas speakers. Este año hemos recibido 42 papers científicos, representando un 68% de incremento respecto a la edición pasada. 21 de esos papers han sido aceptados. Adicionalmente, se han aceptado 13 pósters.
Yes, I'm very happy to see the difference because I have been participating in Carla since 2015. So I have been the last 10 years in all the editions of Carla. It's very nice to see how the growth of the conference, the number of people, the number of participation, the number of sponsors, the number of articles, papers presenting in the conference. So it's a really representative conference from the Latin America community. I'm happy.
Y me llevo mucho conocimiento que se lo voy a propagar a mi grupo. Es una retroalimentación, o sea, de verdad que felicito a los organizadores por este evento y sobre todo porque han pensado en la organización particularmente para los System Administrators y la gente que hace User Support, que no es una cosa común.
Hacer montones de investigadores de varios países, hemos tenido que hablar francés, italiano, lo que podamos para comunicarnos bien y eso ha sido muy enriquecedor también.
Y el contacto, la camaradería, todo lo que sea, los problemas que quizás, como el HPC, un nicho tan específico, aquí he podido conocer ciertas cosas, obtener tips, formas de trabajo. Todo ese conocimiento que aquí se está compartiendo ha sido muy enriquecedor y me dio una muy grata experiencia.
Bueno, para EMED es fundamental estar en Carla. Ya son varias las ediciones en las que estamos acompañándolos. Está en nuestro ADN el trabajo y todas las iniciativas de HPC y de inteligencia artificial y este es el lugar donde se reúne la industria a repensar la actividad, a ver las nuevas tendencias, a ver las nuevas tecnologías. Y para nosotros es importante para mostrar, pero también para aprender, para escuchar.
Es importante en NVIDIA estar en Carla porque aquí están las cabezas que piensan en nuestra región y se puede conocer la tecnología de NVIDIA un poco más. Siempre se acuerdan de NVIDIA por las GPUs, pero es importante que mostremos toda la capa de software, toda la capa de los programas educativos que NVIDIA tiene para la región. Entonces es siempre importante. Yo personalmente estoy en Carla desde el principio, pero este es mi segundo año como NVIDIA, tercero año como NVIDIA en verdad. Entonces es importante porque aquí son las personas que van a crear la computación de alto rendimiento e inteligencia artificial en nuestra región de América Latina.
Más relevante de Carla 2024 para mí es que este año estaba acá en Santiago de Chile personas que son claves del punto de vista de cómo se piensa y lo que va a hacer de HPC. De todos los países podemos encontrar personas que tienen mucha experiencia y que son relevantes en sus países, en sus regiones. Podemos hablar Trusted Advisors que hacen que son las referencias para hacer desarrollar computación de alto rendimiento e inteligencia artificial. Definitivamente, Carla 2024 nos sorprendió mucho con la calidad de las personas y la importancia de las personas que estaban acá trabajando con nosotros.
Para Deli, fundamental por participar en el Carla 24, porque nos permite conectarnos con la comunidad, con las necesidades que tienen los investigadores, los estudiantes, los desarrolladores. Y esto nos permite generar un networking que para nosotros es fundamental desde el punto de vista de entender adecuadamente las necesidades que tienen, de manera tal de poder llevarlas nosotros hacia el interior de nuestra organización y transformarlas en soluciones y poder seguir construyendo juntos soluciones en esta línea.
Primero, que la comunidad del Scalac decidiera hacer un galardón que lleva mi nombre es un gran honor, porque creo que hay otras personas que a mí no me hubiera, sorprendido que llevaran su nombre y no el mío. Segundo, este es el primer año. Entregarlo yo personalmente pues es un doble honor, ¿no? Espero estar muchos años entregando el premio, pero ya soy muy mayorcito.
Y en ese aspecto, el ganador de su premio, Luis.
Luis es una persona que conozco muy bien, que he ido muchas veces a Bucaramanga. Es un gran cocinero, aparte de un ser investigador, y es una gran persona. Yo creo que es muy merecido este premio.
El premio es una gran sorpresa, yo no esperaba, es una sorpresa. Me gustó mucho, claro que me gustó y tal, mas así, no es un premio para Philippe y Navaux, es un premio para toda la comunidad. Es un premio para la cooperación en la América Latina, por el desarrollo, que es eso que queremos.
But now I'm getting sick, and it's only when you're sicker that you figure it out. The world don't make sense when you're down. No, the world don't make sense when you're down. So I try my best not to get down. Now I'm out of money and I'm left here wondering, why did I piss it all away? So desperate.
So after this video, I have nothing to say. Okay, I will give a few words only in Spanish. Sorry for that. So after all, we're in Latin America. I should say it in Portuguese or Brazilian, ¿no? Quiero dar agradecimientos a algunas personas. Esto siempre es desagradable porque uno se acuerda de algunas personas y no de otras. Así que no representa para nada el pensamiento de Ginés Guerrero. Así que te excuso, Ginés. Es mi pensamiento viniendo de otro mundo. Yo soy matemático, estoy emocionado de haber participado de Carla, de lo bien que se llevan. Es impresionante. El orden tampoco no es alfabético, es el orden que me venían a la mente, así que lo siento anticipadamente. A Carlos Jaime, agradecer muchísimo. Ha sido muy interesante conocerlo. A Salma, ¿dónde está Salma? Muchas gracias también. A Carla, nos escribimos mucho. A Esteban Meneses, por supuesto. A José Monsalve, Esteban Moscos, que anda por ahí. A Nicolás, por supuesto, que no sé pronunciar tu nombre, Wolowich. Me va a retar. ¿Se fue? Antonio Russo también se fue, entonces, supongo. A Philippe Navaux, merci beaucoup. Merci beaucoup, Philippe. Il a été un honneur de vous connaître. A Luis Eliezer, por supuesto, muchas gracias. A Isidoro Gittler. Ahí estás. A todos los conferencistas, a quienes organizaron los minicursos, los paneles. Realmente una actividad espectacular. A la organización, por supuesto. Algunas instituciones que me vienen a la mente. A Red Clara, fundamental en dar la posibilidad de que nos juntemos. A Reuna, que es la versión chilena de eso. A instituciones como INRE, CNRES, el BCC, a nuestros hermanos brasileiros, muchas gracias. Muito obrigado. Eu esqueci mi carioca. A nuestros hermanos y hermanas mexicanos, ecuatorianos, peruanos, costarricenses, colombianos, panameños, uruguayos, venezolanos, cubanos, jamaicanos, nicaragüenses. Y dejé al final a nuestros hermanos y hermanas argentinos. A propósito, porque son los que yo siento más cercanos, perdón. A nuestros iba a decir hermanos, voy a decir hermanos y hermanas españoles, alemanes, americanos, suizos, franceses, italianos, neozelandeses, rusos, había un ruso entre nosotros, ingleses y portugueses. Espero no haberme olvidado de ningún país. Por supuesto, agradecer al equipo local. Esto no habría sido posible sin la existencia de un español que está adoptando a Chile como su segunda tierra, Ginés Guerrero. No habría sido posible. Quiero agradecer al equipo en el HPC, por favor, levántense, chicos. A Pedro, a Eugenio, a José, a Esteban, a Ángel, a Alberto. Las vacaciones no van a estar tan pronto, así que falta un tiempo. Agradecer al equipo de comunicaciones también, ¿dónde están? Se me fueron, a Cristian y Alonso. Tienen un trabajo espectacular, el video quedó muy bueno, muy bueno. A quienes siempre están detrás y que no se ven, a José Carter, que está por allá atrás, a Ricardo Martínez. Bueno, agradecer a mi institución, a la gente del CMM y del DIM, que hacen parte de esto posible. Agradecer a los alumnos que nos ayudaron a llevarlos a las distintas salas, a Natacha, que a lo mejor está por ahí, agradecerle también mucho. Nos veremos en Jamaica, espero. Y de manera personal agradecer a tres grandes amigos, a Mateo, Fabricio y a Ulises, que siempre nos acompañan. Así que un abrazo para todos y fue muy lindo y hermoso verlos en Carla. Gracias.